इसमें स्पैम में देखना, स्पैम में या कहीं तो ट्रैश में। कहीं तो होना चाहिए, तो भी नहीं आएगा फिर और क्या, एक बार कंफर्म करेंगे। चालू कर दिया है, सब हो गया है भाई। माइक बंद रखो हाँ सर प्लीज़, यहाँ पे सेंसिटिव इन्फॉर्मेशन चली जाएगी फिर। अंकुर का ये साइन यही है ना, एक स्टूडेंट तो आया हुआ है उसका, तो उसका साइन लिए नहीं अपन ने। नहीं लिए, निकाल के तो रखा हो तो। हाँ लेने का है, जाम खांडीकर का साइन कभी होगा नहीं, वो मुख्तार करेगा। हाँ आएगा तो करवा लेंगे। तेरे को नहीं आना उस दिन अंकुर को गाली पड़ी कभी, परसों मैं तेरे को बोलना भूल गया शायद, नहीं मालूम। हाँ 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 परसों गाली पड़ी सालों। कैसी, किसने दिया? तांबोलिया, तांबोली के सामने बहुत आर्ग्यू कर रहा था कुछ, तो तांबोली राहुल और 2-3 जन थे, आर्ग्यू कर रहा था कुछ तो CSR को लेके। मेरे को तो नहीं मालूम, तो जुमेरात को अपन थे, जुमेरात को नहीं, उसके पहले वाले दिन तू था, उसके पहले वाले दिन बुध को पढ़ेंगे। हाँ जो पढ़ी ना उसको चढ़ी गई, क्या देख क्या, ये सब तेरे को मालूम होना चाहिए। निकाल देंगे ना बाहर, कोई ले रहा नहीं है, चल ऐसा करके भगाया उसका, फिर वो चुप हुआ। तांबुल ले लिया उसको, तांबुल इधर के रिस्पेक्ट में आ गया, ले वहाँ सही है, बंद है ना सब। हाँ तो तांबुल सर आए थे, ये चल रहा सर कैब में कोई प्रॉब्लम वॉब्लम? नहीं भाई तांबुल नहीं भाई ठीक है। मुबशिर आगे करके गया क्या आज? नहीं उसने एक साइन किया है मुबशिर सर ने। ये कैसा आया उसका साइन? इधर किया है साइन, वो देखा ना। नहीं नहीं आज का ही है, कल नहीं था, आज का है। अमृता 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 श्रद्धा मुख्तार, मुख्तार का तो रियाज का भी लिया था, तनवीर का भी लिया था, तुम्हारा लिया था, नवाज का कल हो गया, राहुल का कल हो गया, ये मुबशिर का ये 3 स्टूडेंट का भी हुआ ना, साइन नहीं किया गया फिर। 3 स्टूडेंट का साइन किया ना उसने, 62 का किधर है उसका, आया है क्या 62 का? आया है ना, 3 वाले पे साइन नहीं किया, ये सब पे साइन करना ज़रूरी है, फिर साइन नहीं आएगा तो फिर बाद में फिर अपने को बाद में, ये तो है नहीं, ये रेफर मैडम का है ना, वहाँ पे चला गया। ये वाला बाकी है मुबशिर का, ये तो बना दिया ना तुमने, प्रिंट मार के रखा है शायद। नहीं ये DL वाला है ना, DL वाला हुआ नहीं, आज भेजेगा, DL वाला आज भेजेगा, दूसरा वाला हुआ है। उसमें से 3 तो हैं, इसमें 3 तो ही, एक मेरी बीवी है, चौथी एक उसमें से जो है कौन है, मैडम भी होंगी, नहीं मैडम नहीं, मैडम नहीं बैठी, ऊपर के 3 अपनी है। इसका रिक्वेशन बनाने दो पहले प्रिंटर का, जाके मैडम फीडबैक में ना उसने एक आरती बख्शी करके उसको बोल के रखी है, वो बोलेगी आरती बख्शी। हाँ किसके रखी? ये वाला क्या बोलेगी वो नहीं मालूम मैडम, क्या क्या बोलेगी वो सब नहीं मालूम। हाँ हाँ वो तो पहले से ही मैं भेज रहा था, कल का शाम का एक भेज रहा मैम, अपने शाहनवाज और एक वेदांत यानी दोनों फीडबैक देने के लिए तैयार हैं।
Good morning, sir, and all the participants. We will wait for a few more minutes and then we will start. So let others also join.
का 62 तो आया है, नहीं वो अलग सब्जेक्ट है, CG है, 2 है उसके, देखना रिमाइंडर में है, किया तो उसने बोला भाई मेरा नाम निकाल दे, मैं देता हूँ तेरे को, चालू है। मैं बोला ठीक है, नाम निकालता हूँ करके, तो मैं उसको नहीं भेजा।
ये खाली कॉपी पेस्ट किए।
हाँ, और उसमें फिर मेरे को फ़ोन आया, क्या नाम है उसका, मारूफ का। तो मैं बोला कि वो कल रात शाम में असाइन हुआ है PP2, तो नाम नहीं डाला है करके। अब ये दोनों जो नाम नीचे है उनको बोला नहीं है, पर्सनली बोलने का। अभी कौन कौन कहाँ जाएगा?
कलीम सर तो नहीं जाओ,
करीम सर के पास मैं ही जाऊँ क्या? और तबरेज सर के पास
क्या
कौन
मैं
जाएगा?
जाऊँ सर के पास?
तबरेज के पास कौन जाएगा? तू जाएगा क्या?
मेरे को तो टेंशन नहीं है, मैं तो जाऊँगा बिंदास।
हाँ
मेरे को
ठीक है,
टेंशन
तू तबरेज के पास जा, मैं करीम सर के पास जाता हूँ।
शुरू कब करना रहेगा?
क्या क्या
शुरू कब करना रहेगा? 11
तो वो नहीं, 2 मिनट में चालू करेंगे बोले ना मैडम ने।
हाँ हाँ, तो वही चालू कर देंगे ना। 11 लोग हैं।
उनके ऊपर है मेरे
नहीं ना,
आज
तुम्हारा काम नहीं। हाँ
आज परसों उनको चलने नहीं हो रहा था कॉलेज से जाते टाइम। देयर इज हाई पॉसिबिलिटी वो आएंगे ही नहीं। मीठा वाले मले अल्हम्दुलिल्लाह रब्बिल आलमीन। फाइनली आज लास्ट डे है। किस बात का? एफडीपी का। हाँ ना यार फाइनली। माँ कसम रोज का 6 घर पे पहुँचते पहुँचते 7 बजता है ना मुझे। एक्स्ट्रा एक दिन मैडम 3 दिन चाहिए।
Participants kindly do wait because there is some problem with my laptop, so I am connecting to another laptop.
के खिलाड़ी के हम बहुत पुराने फ्रेंड हैं।
रोहन दास की नहीं हुई ना साइन?
नहीं वो तो उन लोग ने फ़ोन किया था भाई कि सर आप बोलो मैं आता हूँ करके। मैं बोला रुक मत आ तू, प्रिंटर ख़राब है, क्या करूँ मैं तेरे को आके।
नहीं, इसको बुलाना पड़ेगा ना फिर साइन को।
हम्म
मार्कशीट आई है, साइन नहीं है।
हम्म
मुबस्सिर ने एसपीसीसी का साइन कर दिया 3 को।
कल भेजा था शारिक भाई को तो मिला नहीं।
ये क्या मुबस्सिर सर की साइन है ना ये?
ये नहीं
रोहन?
रोहन ये सारी शीटें लेके भेजा था तो जो नहीं मिले वो नहीं मिले, ऐसा है। अंकुर नहीं था कल।
आ जाएगा वो।
हाँ फिर इरफान का नहीं हुआ,
इरफान का पक्का से साइन लेना पड़ेगा।
रोहन का नहीं हुआ, और मुबशिर का तो मैं बोला उसको तो उसने बोला कि सर मैं वो दूसरा वाला भी भेजूंगा ना साथ में आके साइन करता हूँ। बोला ठीक है, मेरे क्या करने के।
प्रिंट आउट निकाले ना 62 के।
तब्रेज सर का है, तब्रेज सर को भेजेंगे ना तो वो दूसरे पे डालेंगे। डोंट कैनॉट डू समवन एल्स।
Till then, I request all the participants to open their schematic with their EV model on which we were working. I'll be just connecting through my system.
इधर पे अपना आते जा रहा है, इधर पेपर डाल रहा हूँ, इधर पेपर बढ़ते जा रहे हैं, इधर रेड बढ़ते जा रहा है। सारे यही है अपने।
हाँ
इधर टोटल मारा, इधर पेपर डालेंगे ना तो इधर ऐड हुआ डायरेक्ट अपने इधर बिल
अच्छा हाँ वो तूने फॉर्मूला डाल दिया ना।
डायरेक्टली आ जाता है। खाली इधर का रेट नहीं डाला मैंने, ये वाला।
डालना काहे के लिए सोच रहे
नहीं नहीं, बाद में डालूंगा, अभी इधर लिख के रखा हो। 2.5 डिवाइड बाई 2
हैं। ठीक है।
याद है अपने को।
कितना अमाउंट बना इस चीज़ का, ये वीडियोस वाले कैप का?
ज़्यादा नहीं है। दस।
10,000 रुपये है, ठीक
वो
है।
बहुत है,
और अपना कितना हो रहा है?
वो बहुत है।
नहीं नहीं ये
इसमें
हाँ 1,000 रुपये
उस
भाई
1000
का
का
जा
इसमें
रहा है।
भाई का जा रहा है 756। हमारा कितना आएगा? 630।
ठीक।
इसमें ज़्यादा बच्चे नहीं है ना,
नहीं ठीक है फिर
अभी
भी
डायरेक्ट सेकेंड ईयर का आएगा ना।
पेपर कितने सारे थे क्या, एक 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 मेहनत ज़्यादा है ना भाई। कुछ
सीओ
भी
के
बोलते
2
हैं,
दिया।
राजू बोलती कि बच्चे लोग ने गलत इन्फॉर्मेशन दिया तो कैसे वेरीफाई करेंगे। मतलब तो
बच्चों
एग्जाम लेने
की
के टाइम पे क्या झक मार रही थी?
बच्चों से तो इन्फॉर्मेशन लेंगे क्या, एग्जाम से इन्फॉर्मेशन
नहीं
लेंगे
तो
क्या, बोल रहा हूँ।
एग्जाम जब ले रही थी तो क्या झक मार रही थी?
अरे
तेरे को एग्जाम लेने बोला था ना।
एग्जाम दूसरा नहीं देगा ना।
तो खुद ने एग्जाम लिया, खुद ही असेसमेंट कर रही है और बोलते हैं कि आई कैन नॉट गारंटी। बोले तो कौन गारंटी लेगा? मैं,
रिस्पॉन्सिबल टू नहीं रहेंगे तो कौन रहेगा?
मेरे पास तो कोई डेटा है भी नहीं तो मैं कहाँ से लूँ रिस्पॉन्सिबिलिटी।
तो देखता हूँ तबरेज सर आए हैं क्या।
कौन?
तबरेज सर, कौन सा तबरेज है उनका देखा था पहले। डीएस किसको हुआ था?
और कल का मेल था ना, मैंने किसी फैक्ट को भी नहीं डाला है।
खाली
Yes, sir, we can start now. Now I am connected with this. I'm just sharing my screen. This will be from Shashank Kumar's laptop, so just enable that.
हाँ शेयर कर सकते हो, हाँ शेयर कर सकते हो।
I hope my screen is visible. Participants, do let me know.
Yes, ma'am. Your screen is visible.
Okay, thank you. And sorry for the delay because there was some problem with the laptop, so I have to connect with another laptop. In the morning, I logged in and I opened that schematic and SCADA also, but it's still, I don't know what's the problem is with the laptop. The screen is not coming up. So, okay, just open that example model where we left. So we were in the mid of this we were designing for the electric vehicle model, and here we stopped. I asked you all to complete this ID reference values. You have to connect with this rotor flux, and till here it was said to be done. That yesterday I showed you about the quadrature axis reference and quadrature axis regulator. So now we will start from where we left. Till here everyone has completed. Means this ID reference box, I told you to generate this flux reference in this C function block, the same method that we have to do. So till here everyone has completed. So shall I proceed further with the rest of the part in this power control train module? Now here what we will do that we will use this DQ to alpha beta block where we will input this ID means this direct voltage reference as well as the quadrature voltage reference. Actually, these are the vector references. So DQ block. So this is DQ to alpha beta block, and I'll just let you know in this help icon that what is it. So in DQ block, this will convert this direct axis current, direct axis and quadrature axis into alpha beta. And this will be the value of alpha beta. Okay. So here we will now connect, and the omega t again we will take a from block for the theta. So this direct axis will be connected to this reference to the direct axis, and this quadrature axis reference will be connected to this quadrature axis. Like this, and for this omega t we will fetch a theta block from block. So this theta will be communicated here. So taking a from block,
आवाज है क्या हुआ
so this is theta block, and we will just connect the matching connection. So it is the go to one tab. Now for this alpha beta, we will connect a gain block, because we will in this SVPWM reference generator. So first I will fetch SVPWM generator. So this you will form in find out in signal processing block in extras. So this is the SVPWM reference generator. From here we will get the signals, that is PWM signals for all the three phases, means A, B, and C. So just have a look on this. So this is actually space vector pulse width modulation. So in this space vector pulse width modulation, this we will be generating the reference voltage vector, which is obtained by joining two non-zero space vectors. So it is depending upon the sector in which the reference vector is located. So this is the alpha beta frame, and from this alpha beta frame we will get this SVPWM reference signals, that is MA, MB, and MC we will generate as the output. So this alpha beta will go into the input of this alpha beta block of this SVPWM. Because in every PWM period, this statement is written here that the reference voltage vector will be obtained by using the two adjacent non-zero space vectors, and it will be depending on the sector in which the reference vector is used, as it is shown here. So like this, for this quadrature axis and this direct axis, we will be using this. So this execution rate is will be inherent. But before that, we will multiply with some gain value. So we will use a gain block. So this in this gain block, it will be 1/205. We will divide by this 205. It is just a constant value because we want KV difference. So it will be, and the same gain block will be copied for with the same values for the beta section. So this is will go to alpha and beta. Now we will get the signals that is about this MA, MB, and MC. These are the reference signals for PWM. So we will fetch signal input means output port. So, or we can say these are the modulated signals. So define it as MA, MB, and MC. Right side will be right and indexes will be 1, 2, 3 like this. Define the indexes, that is right and 1. For the output ports, right and 1. Sorry, right and 2. This will be 2. And this will be right and 3. Now this control logic we have completed for this electric vehicle. This is our train control module. I'll just save this file also as well. So now get back to this electric vehicle. So these are the signals which we got MA, MB, and MC. Modulated signals. Either we can connect directly from here or we, as we will requiring in this connection logic. So we will just use a go-to blocks for this. And we will make these signals as local. Use go-to block and make the signals local.
मैं जाके आता हूँ किधर आया था क्या एडमिन में आया था मशीन सर किधर है इधर आज तो भाई आए थे क्या नहीं मैं फोन किया फिर उधर सर आपने फोन हाँ सर मैं आता हूँ ऊपर 2 मिनट में ठीक है भाई आ जाओ सर का डेट पहला था लास्ट टाइम उधर क्या करना है
Once we change the name, that is
बात सीधी है एग्जाम सेल हमारे और तुम्हारे बीच की है बराबर कल की दादा ना 14
MA,
हिसाब से एग्जाम सेल ने भी
and it is local.
मेरे को तो
So connecting to it,
कि मैंने यहाँ से चुगली किया है।
copy the same,
मार दे print अगर
change the names only MAMB, and this one is MC.
तो 3 रहेगा ना भाई सर print तो कॉपी की है ना नहीं सर देखना 1900 डाल के रखे 3 रहेगा ना भाई डाल दे अच्छा इसके लिए बोला
This control we have prepared. Now these signals MA, MB, and MC we will be giving through signal from
सर बोले कि तूने भेजा क्यों नहीं करके
so once we make the change, so this is MA, copy the same and paste it.
ठीक है भेजेंगे अभी सब लोग ये एक्सपेक्ट कर रहे सर मेरे हिसाब से वो तबरे सर भी यही बोलेंगे तुमने शीट नहीं भेजा करके
Just name it. This one as MB, this one as MC. So this MA will go to the input port A of this internally modulated this three-phase inverter. This MB
उपाध्याय के पास जाना ही नहीं है उपाध्याय का नाम उसने भेजा ही नहीं है नहीं है ना उसका एक है हाँ वो तो भेजा ही नहीं है तो वो करना आएगा तब ये कराएंगे उससे
will go to the input port, and this similarly this MC will also go to the input port of input port C. Now for enable part, we need to generate this start motor, means how to start the motor, that will be the enable part. And so for this we will be generating a subsystem, that is connection logic. In this connection logic we will be using these logic gates. So again a subsystem will be required. Read all these parts. And now in this, the first portion which we will perform is that we will check if vehicle has stopped or not. So for that purpose, we will provide speed to the input of the comparator. So the first portion, that is check if vehicle is stopped. So this, for that I require a constant also for assigning the tolerance. So you will find in the signal processing extras, I'll give it as name 1e to the power -3. Name it as tolerance. Name this constant block as tolerance. Now use a comparator. So comparator is also given in this logic section. Now this will go to the negative input of this comparator, and we will be providing the speed from the input port. So this is my input port and name it as speed. So this one is fixed, okay, and the side will be left and one. So now here we will be comparing this speed, and after the comparing this speed, the output of this speed will go to the logic operator, and that logic operator will be NOR gate we will be using. So use the logic operator, that is from the signal processing block. So change this operator as NOR, and number of inputs we required two only, and signal means this execution rate will be inherit itself. So this is the connection logic we are going to follow up here. I'm just hiding this name because lots of components needs to be assembled, and with the name of this NOR and other, you can judge that we have used this NOR log. Now for this start motor, we will use again a signal input port. Copy this.
मेरे को दिए थे सना वो वापस चाहिए दो जितने भी मिलेंगे दो दे दो एक बॉटल एक खाली है दूसरी खाली हुई नहीं
Signal input port, and we will keep the index as
मतलब ये वाली नहीं चाहिए ना तो अच्छा ये वाली मेरे को ज़बरदस्ती ख़त्म करना पड़ेगा क्योंकि मेरी मम्मा बोलती थी घर पे मत लगा बाहर लगा
2. It will be on the left side, but we have to only change the index. So now this will
फ्रूटी वाली
go to the NOR gate. This input will go to the NOR gate, and the same input we will be using this start motor input in other logics also. So I'll just copy this and paste somewhere at the bottom, and here also I will be requiring, so this one. Now here I can change this input as AND gate,
वो दूसरे वाले जो दिए थे ना सना वो क्या करता है अब देना पड़ेगा अब शायद नहीं बोले मैं बोला बोला शायद उसको बोल दो
and this one as OR gate. This is how you can change the logics. Now when this start motor is given to the input of this NOR gate, the output of this NOR gate will go to the first input of this OR gate. Now here we will actually, in this OR gate, we are designing logic that we have to close the contactor if our vehicle is off. We have to close the contactor. So we will add a comment over here. Close contactor if we have certain condition, like this is vehicle is off, or means off means also it is not in a motion, so and motionless. The other condition, the first condition will be this, and the second condition which we will be providing is that
राजू के तो अपन ने जानबूझ के किए हाँ वो मारूफ को कर देना मैसेज
if contactor is blocked by the charger.
एग्जाम लेने टाइम पे किया वेरीफाई अभी ये मेरे को मैसेज लिखा रहा है कि मैं जिम्मेदार नहीं हूँ तो मैं तो बुलाऊंगा ही ना इधर आकर तू साइन कर और तू जिम्मेदार नहीं तो मैं क्यों जिम्मेदार बनूंगा भाई
By the charger. So this is here contactor is blocked by the charger. Now for this or input we will provide another condition, and for that we have to provide because second condition what I defined that it is blocked by the charger, so that charger condition will be input. As of now we will go through when we will design this charger logic below, so it will from there we will connect the output to here. I'll copy this AND gate again here. We are going to design the logic for the charger in and for the contactor also. So copy this input port and paste it, then again paste it. Now here just name it as charger in, means when it is in charging. So charger underscore in, then okay, and contactor FB. So this input this is 3, okay, and this one is 4. Okay. Now this input will go to the OR gate, and now here the what we will get, that the contactor output, that if it is switched on or switched off, it will close the contactor. So this will be a kind of contactor output. So we will use the signal output port. So for this signal output port, this is one and this one is another. Now here, this is the contactor. Kindly go through this example model also if I'm going somewhere wrong. Right now, but my logic is going correct. Yes. So now this contactor will be closed. So it will close the contactor. Now for this closing the contactor, now this contactor command is over. Now here what we are doing, that is we are block contactor from opening, means contactor will be blocked if we are connected to the charging. So this logic is defined for this purpose. So block contactor from opening if while charger is connected. Is connected. So this is okay. So this logic is for this part. And the output of this, what we will get, so another output port, I'll just connect to this. Copy this and paste. So this output, on this output, what we are going to get, that charger is connected. Charger is connected. And now we have to, so this side we can keep it as earlier one was right one. Now this charger is connected. Now we have to work for the logic of the motor, that is either motor is on or not. For that also we need to put a condition. So right, and this one has 3 and this one for the motor on. So right, so this is motor on. This output we will require for the motor on. Underscore on. Now the condition which we will give here is this, that turn on the motor if start command is on. Start command is on and the operation and charger is not connected. When these two conditions will satisfy, so then our motor will on. Now here what we have to give, the output of the AND which we are getting is charger is connected. So we will use the NOT gate for this purpose. In order to give input, copy, making a space. So now this is will become NOT gate. Okay. Now the output of this NOT gate is charger is not connected. For the start motor, this we will give here. So now this connection logic is completed. Best fit zoom. Yes. Contactor command, then motor on, then charger is connected, and this is vehicle is stopped for this purpose. Now this is your connection logic. I'll just enlarge a little bit so that we are able to see the commands. Name this subsystem as connection logic. Logic. Okay. Now this contactor command will be where it is open. This is the switch. Okay, just go to inside. We have to change the index of this. Because contactor FB, we will be getting as an input from the contactor. So this should be at the right side 3. I'll just check on 3, and this will be on the left side 3. Come back, let's check. Now this is the contactor command logic, and this is the delete. Just so this is the contactor command, and this one the output of this contactor switch which we have enabled through the logic, this will go to the input of this contactor FB. Now these speed and start motor we will give through SCADA, and the speed we know that from the from block we can take it. So signal from, and this is our speed, and speed is WM. Make it local because we are using in the same connection. So this is now for the start motor, give the SCADA input. So this is the SCADA input, and name it as start motor. Start motor. Change the parameters accordingly, that 0 and 1 logic we will give because inside we have created that logic only. So here 0, 1, and execution rate as TS. For this charger input, we will use the input port, and the charger where we have designed, from there it will fetch the charging, and just name okay, just click on this and make this left, and port will be 2 because in the charging station there the port 2 is open, so there we will use 2 and hide the port label. So, okay. Now for this charger connected, we will use a SCADA output with inherit signal and charger connected. Charger connected, and for the motor on this logic which we have prepared, uh, we will take through distal probe also, and we will use the go to signal for this. So first fetch the distal probe. So for this digital probe, this is I will use motor is started. Okay, and also signal go to because we need to provide. So tag name is start motor and make it as global. Start for motor, make it as global. Because inside some of the subsystem also we have used this. So it needs to be made global. Now this connection logic part is completed in PCM IFOSC. What is left is IA, IB, IC signal. So these IA, IB, C signals we are getting from this three-phase meter logic, and now we will use this from block. Zoom a little bit. So this is IA, IB, and IC, and all. So IA, copy this. For from also, for omega m also we will require the from, And for throttle, we will be providing the SCADA. Name this as IB. Then IC. This is omega M, means WM. For throttle, we will take this SCADA input. So this is throttle. And in this SCADA input, the values will be as same, only we need to change the execution rate. Even if we do not change, then also it's not a problem, because by default it is like this. Otherwise, this electric vehicle part we have completed now with the subsystems. So come back to this route. Now connect where we left it blank. The part which is left only to initialize this images, but before initializing the images, we will just compile once, and let's check if there is any error or not. Okay, enable is not connected. Yes. So look under mask. This enable is not connected, and this enable is nothing but this is the start motor. So use the from block for connecting the enable. So this will be our enable, and name it as start motor. And this is global. Start motor is, make it as global and connect. Let's compile once again, and if there is any something left, till it is input IQ is not connected. Go to the theta calculations. Yes, this input IQ is not connected. We will just connect this. That is inside the control. There are lots of things inside the control, so we forget. So IQ, from where from this portion we are getting IQ, so we can connect. Now save. So till then, yes, it is in grid resident inductance property inductance of the component in the grid residential load. So go to this. Okay, load 3. So go back to the root and in the grid residential load. Look under mask. Load L3. We'll check again with the values. So it is VB into 2, then upon SB, then we have taken the square root of this R factor. Yeah, inside this, I forget to put this B, small b. Now it's okay. We will check for the same in L2 also and L1 also, because this I have copied. Now here it is given. In L1 it is again missing. So FB. Make a correction even if you have left. Otherwise, if you would have copied from example, so it may be correct. So I missed that B subscript. So that was a small error. Just let compile. Okay. Again, it is showing error in load 2. Here also we missed FP. Come back to this grid residential load, and here in grid impedance also we will check if there is, otherwise again it will show. These are sometimes very small errors, and we usually overlook these things. Check the values of this inductor, and so because we have copied these values from here, so it is, that's why it is showing. Okay, fine. I'll compile. The portion which is left, it is only to stick the figures. So now there, I think there is no errors, I guess.
Hello,
so
ma'am.
Can start with, yes.
Ma'am, I got an error in that capacitance which we have put in the electrical vehicle.
Check the value where you are getting the error. Just let me know.
Ma'am, can I share my screen?
Okay, I'll just stop share. Just share your screen. Let me.
1 minute, ma'am. Is it visible?
Yes, it is visible. So just install.
Ma'am,
Yeah.
this error.
Electric vehicle 3. Just electric vehicle C3.
Yes, ma'am. C3.
Okay. Open that component. You must have not assigned this CF is the filter. Have you assigned that?
CF. This one, ma'am.
Yes, this is correct. Okay, press it OK. Go to the model initialization. Is your CF assigned there?
No, ma'am.
You will just do one thing. Go to your example model. Go to
1
your
minute, ma'am.
example model.
Yes, ma'am. 1
Okay.
minute.
Go to your example model. Go to model initialization, and after this TS, whatever it is
Okay.
written, copy full. Copy full.
Okay, ma'am.
Means the TS you have already allotted, and copy all these statements. For everyone it is. Even if you have not assigned. Just check on the model initialization once again. If you have taken TS twice.
No, ma'am. I have copied all, and then I'll. Just 1 minute, ma'am.
Okay, just hold on. Okay, if you now your errors must have been rectified. So you can stop share your screen. Again,
Okay,
if you
ma'am.
will feel problem, just let me know.
Okay, ma'am. Thank you, ma'am.
Please mute yourself. Okay. Now here, what the portion it is left? It is just to left that to stick the figures. So the figure criteria is the same. What happened? Was I? Has it been loaded to the SCADA or not? I just check. Okay, before going to this, I will compile and load a model to the SCADA. Until then, it is doing. We can do one thing that we can minimize this part. And now go to your computer, the C drive. Go to the users. Then go to, I'm going to my folder, and you can go to your folder where is your this Typhoon Hill is. App data, then roaming, then Typhoon Hill. Then in mod examples, models, automotive, electric vehicle. So here you will get this image folder. Just copy this. Create a folder. EV2G. Okay. Open this. Paste that folder. Bring all the files inside this folder. So this is now in the same folder. Now open it and you will get all these figures. the same method which we did on that part. So you can do it and your figure will be generated. Similarly, for this charging station, also do the same thing. Images and your this file should be in the same folder. You can copy the component description, but component description we have already done earlier. You must be having, but as I changed the PC, so it is missing here. You will get now for the same thing for the electric vehicle also. Go to the mass editor, copy your appearance. Press it OK. Now I will save it once again. And now this has been designed. Now I will compile and load model to the SCADA. नहीं, time नहीं है अभी. Algebraic loop detected, that is switch 1. Then there is some problem in the connection logic operator, so I'll just check. Okay. Connection logic loop, there is a problem. So I'll just check with the connection logic. You also just check with your connection logic if we have done something wrong. Here we find to be correct. Then this is
Man,
coming to the
after the
semantic.
contact block, we didn't have that unit delay. That's why.
Yeah, contactor block. Yes, yes, correct. Unit
Yes.
delay we have not taken. Correct. Thank you for telling. Unit delay. So give it here, the value is 0 and everything will be fine. Just it will be yes, correct. Now I'll save this once again, and now I'll compile it. CTC wrapper, okay, logic. Till it is loading, I would just like to show you in my Typhoonil control center that today I am connected to this hardware in loop box. This is a real-time emulator. Can you see? This my HIL device, it is showing USB. Are you all able to see it? And
yes, ma'am. Yes, ma'am.
and here also this is the look of the box. I'll just show you by so it was showing that there is some firmware update problem. So we will just check. It is asking it in order to update the firmware. So here it is connected. I'll just minimize this window. Just close this, minimize this one. Now we will create a panel. So till then, what you can do that you can just save your model settings in the same form. The settings which we have done in our this schematic, the same settings file is there. So in the form of .runx, it will save. So come to the panel. The first and foremost thing which we are going to do is that first we are going to take a group widget. So from this group widget, you can take this. This is your group widget. As I will place some of the components and we'll start the simulation, and with the same time we will be able to observe some more of the things. So now here you can put the image. I will just show you putting image of a car, and similarly for this driving dashboard, you can take the images by yourself. Otherwise, you won't be able to see the pictures properly, means the results, because in dashboard it is too minimized. I'm just telling you that how you can get the images from here also. So go and select the image. So I'm going to my, here also you can frame your image panel. Going to my folder, and this is, so I will take this image. So this image has been taken. here the option it is given, you want to give the aspect ratio, or you want to change the aspect ratio, that is as per your requirement. Otherwise, if you want that, you can ignore the aspect ratio. And okay, so now this you can enlarge it like this. I will be using one image only here, and rest of the images you can design, because this will again take some of the time, and in your free hours you can do. Now inside it you can place a sub panel, and this sub panel we will be observing for this battery portion. Just to show you the results. So now just click on the sub panel and go to the properties of this sub panel, and in this properties of the sub panel just write it down, battery. So this is the battery portion. Then go to the widget setting, advanced setting. This image you can now select your battery image from here, and go to the images, then select this image and open, and we will go ahead with the aspect ratio. So see, this battery has been placed like this. You can perform. I'll just go to the properties. I'll do it ignore aspect ratio, so that we can perform the scaling. Because if we need to place a text box, then we require. If you ignore this aspect ratio, you will be able to minimize and do it. Now here, the first and foremost thing, for the battery, we need a bar graph. So we will take a bar graph. Just in SCADA, please, if you skip anything, just note down in your copy. Otherwise, you can go ahead with the example, because I am shortening this SCADA. I will not be using the repetitive components. I will be using everything new here. Means repetitive components, like if the same thing is used for the same purpose, so I will not be using it. Okay. So here I am making some changes in SCADA in order to. So what I am going to do, I'll just minimize this bar graph so that I can place. Click on this figure and do send to back. So these components, whatever I want, that will be placed here. Okay. Now for this bar graph, click on this bar graph. Name this bar graph as, actually this is your battery SOC we are doing. So for that purpose, battery SOC. SOC. Now here you can do one more thing, that you can fetch from the analog signal, but analog signal you have to perform the same things here. So what we can do, keeping this update rate as same, later on we can increase it if it is required. I'm just going with the expressions. So in expression, we have to only do some of the editing part. We need not to perform so much of editing. So instead of this, using this analog, so this is Where the name it is given like bar name. So what you can do, give the bar name as battery SOC. It is connecting right now. Was my screen visible till then? Because in between I find out that I was disconnected with the network of this.
Yes, ma'am. Yes, ma'am. It was almost
Okay,
visible.
so here, okay, so in the bar name, you will write the name battery SOC. Now for this value, you can put it as, we will edit in code editor, and from there, from the SCADA output value, we have taken this battery. So in this value, before this comma, we have to insert that code, that is SCADA outputs, and this is the battery SOC. Bring the cursor and insert the code. So you will be able to insert this code and give backspace for this comma. So this is the SCADA output value, electric vehicle battery SOC. Okay. So this is how you can insert the code. Now for the units, we are not defining any, and for the minimum and the maximum value, we will be defining. Maximum value is 100 and minimum value is this. Bonding, we are going to increase it, decrease it. You can keep it according to your will, but here I can keep any of the values. Either you can keep 10. I have tested all these values with analog also, so there is no issue. You can keep your own values. Means when it should give the warning, when it should be the typical. So all these, now the code is completed. Just save this code. Save this code and close this code. Now I will start the simulation. As of now, it is running in virtual mode. I wanted to show you that hardware in loop box, but problem was that the firmware is not updated, so it is not running in real time emulation. But here you can see the results. We will require a text box. So here battery SOC is showing as our simulation is running. Just hold on for a while. I'll just save this panel and I'll just try to update the firmware. If it'll take a long time, so I will not be updating. It will hardly take 1 minute. So I'm saving this panel as here. So because you can also check that how do we update the firmware. So when you get this box, go into the additional tools and go to the firmware manager. So there the option it is given updating firmware. This is how you can update the firmware when you are connected with the hardware. So by default, you also learn to use this, how to update the firmware as it was not updated. Are you all able to see that we are updating the firmware with this HIL means hardware in loop box?
Yes, madam.
Okay. So if you get a chance and if you get some
Madam,
sort of
through this
error,
firmware, can we update from HL 402 to 604, or it is just to connect the hardware only?
no, this is the hardware box. So in hardware box, you have to use that particular box. If you are right now, I am having with me HIL 402, so it will show the HIL 402 itself. If you want to work with 604, so that's why it is charged. It is means it is costing now. Otherwise, in virtual you can switch, but with this you cannot switch. With this hardware HIL box, you have to work in that particular setting. So again, I am compiling. Heavy models always take a little bit time to compile, and till then I am instructing you. You can fetch your text display box from this library of this SCADA. Text display is present in the monitoring. We will require two sort of text display. So now it has been loaded. I'll just open it, and now here I will start the simulation. So now here you can see this mode. It is showing a real-time mode. Are you able to see on your screen?
Yes, ma'am.
Just move your screen a little. Yes. So now we are working in real-time mode. So I'll start the simulation along with this, and along with this, we will be framing the components as well. So for this text display, I'll just drag and fit into the box. Then I will show you the value. So this box is placed here right now. And now click on this, just name it as text display, copy this, name this, copy this name, the same name, and paste it. Now you can add it in code editor. So here we have to edit some of the things. Just press enter after this, before this block, because we will be using these lines. So I'm not using the 3 or 4 things which we require. First, we write to insert power, then this means control power, power train, that is. So for that purpose, one line, and another line for this kilowatt power, then another line for the enable, and after enable we will assign the colors for it, and you will find the colors. Now for this, go to this other commands, and here I am writing the command for the power. That will be equals to you have to select this charging inverter control dot p. Yes, this is this control dot p. Fetch this one and insert. Okay. Similarly for power V, you have to again go to this and fetch this electric power P underscore kilowatt. See these, if you understand the concept, and so similarly you can fetch all these things. Electric vehicle P underscore kilowatt. Yes, this is there. Bring the cursor and then insert this code. So this is P. Now for the enable, we will use the digital signal, that is motor is started, because from there we have assigned this digital probe in schematic. So go to the digital signal and fetch electric vehicle motor is started. So after the charging station, you will find it. This is electric vehicle motor is started. Bring the cursor and insert this. So this is electric vehicle motor is started. Now we will use the color concepts. Now, what is this text display data? So I want it for text display data as green. These are the colors which we can choose. It is showing it as an example. So green, and make it as equal for the text value. What kind of a text value I want? So I want this sort of a text value. And write it here green. It is giving you a hint. For this, you do not require to learn any sort of a particular coding. Now, what you have to do, just copy the same code from text display green till here. Copy and paste. Then again, you have to paste it. Now here, green is okay. Now we will do it for red. Red. And for this red, we will going to change this display. You can keep your own display according to your choice. If you want to keep it something else, then instead of green, write it here red. So it will blink it below. Then here our status, now for the standby status, or when we start the simulation, so make a capital O and orange. So for this, making it orange and using this symbol. For the text color, write the name as orange. So here it is. Now here the display value, how it will display the value, whether it should be red or it should be orange or it should be green. So now here we will give the mandatory commands, variables which we require. So just before this line, we will use if enable. Under this if enable, we will have a condition. What is condition? That if power is greater than 1 and or power V, that is kilowatt power. So see here it is showing. I use the square bracket, that is wrong. So just keep on things checking that whether while writing these problems occurs, small problems. So power is greater than 1. Then it will display it as, display value will be red. Display data red. So this red arrow, this arrow will become red if this is the condition. Now, as we have given the colon sign, so you will give an indentation. Okay. Elif, because if we are putting a particular condition in Python, so we put elif. Power is, where it is less than -1 or power V is less than -1, then give an indentation after the colon, then it should display value will be green. Copy this, change the color code. So this will be green. Make note of the font which we have taken. So it will take like this because here we have assigned G in capital. So after this, else inside this loop also else indentation so this color will be now orange. Now copy this line with else. This else was under this if condition, and under this enable also, if there is not such things happening, so this will be the condition. So else this display value will be orange. I hope you learned how to write the code. Just save this and close this. So right now, as we have not increased the speed, so it is showing here in orange color only, this display. Okay. So means our text display is working fine. What do you have to do? For the car dashboard, I'm not using that picture. You can use that picture because as timing is running. So I will simply place the components which you require. That's what I'm going to do. as of now. So for this car dashboard, what we require, the first and foremost thing that we require a gauge for the motor speed display, where we will be watching this display. So this is the gauge. Copy this same widget and place it here. This will be for power. Now click it on this. Use label. So now we will use this electric vehicle mechanical speed. In kilometer per hour. Okay, I'll just type it because there are so many components. Electric vehicle mechanical model speed kilometer per hour. This mechanical speed we have got. We want mechanical speed in kilometer per hour. Yes. Before that, somewhere I looked. Yes, this is this kilometer per hour, and here just click on auto assign, and this is kilometer per hour. Press it. Before pressing it, okay, go to the advanced settings. So in advanced setting, just to bring it maximum to 250. Or you can keep it your own range if you want, but here how to assign the warning here, just look, have a look. So here it is 200, and here you can keep it as 230 somewhat. Then here also you can keep it as 200, 230. Means different sort of ranges you can provide. Now for the critical range, you can put the value like 230 to 260. So the colors will come for warning. The color will come as orange, and for this critical range, the color will come as red. Now, user text means display, digital display for motor RPM as well as for the distance. So here you can have the display widget, digital display widget. So this is, I'll just shorten it. one display for the motor RPM, copy widget, control V. So motor RPM and this torque and one display we will be requiring for this mechanical conversion. This is like you can arrange. And now here for the motor RPM, just write it down, name as display motor RPM. Motor RPM and your data type will be expression. So what you have to do that from the display value which is given it as 0, just delete the 0, only 0. And from your analog signal, just bring this. You have to read the machine mechanical speed here. So this is the machine mechanical, and just click it here and insert this code. So this will now read it as machine mechanical speed. So let me check with the code. And now here what you have to do that you have to divide this value by 2 upon pi. So for writing pi, we require np.pi. So np.pi into 60. Just save this code and close this. Here you have to display the unit, that is RPM. So the unit will display it as RPM. That's it. So when we will increase the speed, then right now it will not show. So for this speed also we need space for the widgets. So this battery SOC you are observing, this test display you are observing. This is battery. Now, this group, I can name it as car dashboard, because here we are providing the car details. So it is car dashboard. So nothing else. Just I made it car dashboard. Now for this, this is about the total distance. So this total distance, again, you have to read it from your, so write it down, total distance, and this distance using as expression. So display unit will be in the form of kilometer. By changing the update rate, it may fast the things. So display value, read the analog signal where it is given electric vehicle model speed. So where the electric vehicle will be present. After the charging station. Yeah, power consumption I can see, torque I can see. Yeah, this is electric vehicle mechanical model distance, and again divided by 1000 because it will be in meters. So 1 e to the power 3. Save this code and close this. So now this is it in distance. Now for this gaze, this particular gaze is for the kilometer per hour. Means this is sorry, this is for the watt purpose. So you can clicking on the use label, this gaze one name will be gone, and you can now fetch auto as now this will be in the watt, means kilowatt. So this is kilowatt. Use the analog signal, that is electric vehicle P underscore kV, kilowatt power we have to fetch from here. Yes, here it is. So go to the advanced setting. Here also you can assign the warnings, giving it here minus 200 to 600 if you want to give the warning, because we require to give the warning as used in the coding, that if this is above range, so 300 to 400 warning range you can give. Then this is 400 to 500. Then 500 to 600. I'm running the simulation meanwhile also in the real time, because as I will put the slider for the speed and we will be moving, you will be able to observe the results along with this as we are preparing the schematic. So this is the advanced setting for this. Now for this display for the electrical torque. So for this also we have to do the same thing, that just select this electrical torque. Electrical torque. So this is the electrical torque, and we will take the machine electrical torque, and the units will be auto assigned. So this is the machine electrical torque. Now for this is for the power consumption. So means average consumption. Here you can give watt hour per kilometer. Watt hour per kilometer. So you have to search for average consumption in an electric vehicle, you will find. So because in machine model only we have done. So this is the name, and just press it OK. So now it is there. Now the most important part of this car dashboard, that we have to put the sliders for the speed and start or stop button. But first we will put the slider for the speed, because there are lots of setting in this slider. So I'm fetching this slider. just minimize a little bit so that I can place it for the braking also at the same side. And for the same time as I will prepare this part also, so you can see for the so here the same slider, copy this widget and paste this widget to the this side. Now make a note of it in this slider portion. We are going to edit in code editor, and this slider is name it as speed reference. So this is speed reference. The square brackets open and the percentage sign we will put. Now in this minimum and maximum value will be step 1, and then is edit in this code editor. What we have to do is that it is given in your SCADA inputs. So in this SCADA input we will insert the speed as we are taking it as reference. So this throttle one will be inserted because in SCADA we have taken. So bring the cursor at the 7th line and just insert this code, and where it is written 00, because we will be changing according to our wish. So just type it input and below it comes. If you find any error writing an input value, so make a note of it that V is capital inside this, and save this file and close this. Now we have to make more editing in this widget settings. In advanced settings. So in advanced settings, on start, first I will use on start. So our custom code is written here. So we will customize the code here. So our widget value will be 0, 0, and enter it. And the same code, the method we entered there, this throttle value, the same value we will enter, and instead of input value we will write widget value. So this is widget value, as you will write WI. So now this is there, just click it and now save this code for the start handler. Now come back again to this, go to the advanced settings. So on start timer, we have written the code. On timer, we need to write on timer as we have not checked it. So here we will define the motor state, and what will be our motor state? So it is if this your motor state motor state means underscore state is equals to 0. So the condition applies. What will be the condition? The condition will be this, that this Wiget value is going to be 0. So make a note of it. This Wiget value is going to be 0. So press it OK. Go to edit in code editor, otherwise it won't save the code. And close it. Again come to this window. Now go to this advanced setting. Advanced settings. Yes. Now pick on is on stop and go to this stop folder. There we will customize the code that an on stop, its value is 0. So just edit in code editor and save the codes and close it. Now our this slider part is okay, but slider part will show error as of now because we have to put the start and stop button because we have customized the code for a start and a stop. So now we will customize the code for start and stop button. So for this purpose, I will take a button Wiget. This is my button Wiget, and I'll enlarge a little bit. I'll place LED also besides it so that it can blink. So this is LED is placed here. Now for we will write code for the button. This button is now start for us. So as we will click start and stop. And for this, now here we have to write the codes in code editor, and for advanced setting also we need to write the codes. So go to edit in code editor because you will be making use of some of the inputs. So first statement, if this motor state is motor underscore state, zero, then give the condition. What will be the condition? We will take the output value of the charger connected. So from the SCADA outputs, you will take this value. So this charger will be connected. If motor state is 0, so charger will be connected. And this charger connected value will be equals to 1. If this happens, if charger connected value equals to 1, then give a colon and then indentation will occur automatically. So we will print caps lock of print inside the inverted commas unable to start the car while the charger is connected. The same code which we defined it as in connection logic, the same comment we are writing, charger is connected. On the same logic we are working here. Now give the inverted comma closed and close the braces. Then bring the cursor back, I want to place the else condition. So else condition, here I forgot to give if. Yes. If and else. Else. If this is the condition, this is a condition, so charger will be connected and it will print like this. Otherwise, come to this SCADA input value, close this and come to this SCADA input value. And what we will take electric vehicle start motor. So this is the code for this start motor. Yes, below 9 number in my it is showing. So I will take it as value 1 because it will be inserted. So take it value 1 and press it enter. If it is in pink color, so it has not taken the value. So under the inside this condition insert. So this is your motor will be started and now your motor state is going to be 1. So this is your motor state. Now motor state automatically it comes. So that will be equals to 1. Then else for the first if condition which we have given, for the first else condition, else keep this motor state 0 again, motor will be 0 and insert this. So now, as of now, what will happen? Your motor state is 0. So that is equals to 0. Copy this condition because this condition we need to give in its advanced setting also. Copy and save this code. Close it. Again open it. Go to the advanced settings. For the safety, I am saving the code one by one and closing it. If otherwise, you can write the codes all together and you can do it like that also. But as of now, I want that this code should not be missed. So I'll just reduce this condition else if. So this is about the motor state and we will give the throttle because we have not given. So here we will define about the throttle because this is the condition. Insert this code for the throttle. Okay. Just save this code and we will check once. So this is for the on start. Let's see if there is something for the on stop. So on stop, no, there is no code written and that's why what we want. Just check for the on start is syntax passed. Syntax is passed. For the basic settings also check for the syntax passed. Error in this macro code. Okay. Bring this cursor a little bit to this. It was indentation, so that's why it is showing. Again, I'll check. Now the syntax is passed. So keep a note of the indentions and other things now. For this LED section, also I give this value. Then we will check for is this a start button is working or not. So here you have to do the same thing. So use label and then this, you have to select the digital signal, that is electric vehicle motor started the same. Sorry, it is charging the status, it is electric. Electric vehicle motor started. Now the electric vehicle has started. Go slow, go slow, go slow. This is electric vehicle motor started and press it OK. So this is my start and stop button, and what I'm going to do, I'm reduce a little bit so that only the spelling should is visible, and this I will. So it is okay. A motor state is not defined. Just check on the advanced settings of this, and then we will check on the slider because some settings are given there also. We will check with the slider. Slider will be working well, but due to this for this speed reference, we will check the values because codes we will check. So it is input value in this. Then for advanced setting, we will check wicket value is 0, and this will be vehicle throttle wicket value. Then on timer, 0. Then on a stop, wicket value will be 0. Now let's check the code syntax for all. I'm looking into the
Ma'am, your voice is not audible.
error. Yeah, actually, I'm checking onto the error, so that's why I'm not.
Okay, fine.
Because there is some error in the widget. It is shown that motor state is not defined. So just checking for that.
Okay, ma'am.
So till then, what you all can do till I am looking into the errors, you can design for this break. So on this break, we will for the break slider, we will provide it as break percentage, and then we will check if the widget is again not working. Then we will check break. Then go to edit in code editor, and from the SCADA input value, you have to fetch the value of the model break it is given. So this is the break value, and I'm going to insert it, and instead of 00, put it as input value. Because these are some of the sliders and widgets which are connected to each other. So just let's check after assigning values to this widget, is it working or not? So yes, I want to save the code. Then again, click it on break, go to the advanced settings, because these advanced settings matters. So this will on start, and the widget value will be 0 as of now for the break part. And then again, you can insert the same method, this break insert. and this is your wicket value. Wicket value, and I'll close it, save it. Again, come to this advanced settings. Check on timer also. The value should be none. For stop, it should be none. Okay. So we'll start the simulation and just check with the wicket. Yes, due to this break value, it was not showing. Now the wicket is working. Now next, we want to get this LED for typhoon, means regenerative. So providing this, I have not increased the speed yet. As I will place the graph speed, then I will increase it. So here I am placing for this regenerative, because these are some of the important parts. Battery SOC graph you all can do by yourself, but this portion just look. For the LED settings, go to this regenerative braking, so this regeneration. And this will blink as green color. Change the color because there we have taken it as, and here this instead of this, make it an expression, because here we need to write the codes, because we need to fetch these signals. So we have to define the display value true and false for all these. So need to define a condition. So first and foremost condition, we need to define a power. That is the power control train module. That is power here. So now we have to fetch this electric vehicle power and insert this code inside it. Are you able to get me that what I am doing here in order to design the widgets?
Yes, madam.
Because
Yes.
if some, okay, thank you so much. If power is less than -1, then you can give the colon and the indentation. Indentation is, copy this, we will display the value as true. So display the value as true. Else display the value as false. So we need to provide the indentation. So indentation will be provided. Now close the code and save it. Don't forget to save it. Now for the speed graph, because that is important part of this. Then the status. So as I will increase the speed, the things will go on. Means on the graph, you will be able to see the XY graph I am taking and minimizing it. So that you can see on the same wicket, and I'll copy the same and paste it. This is my car dashboard wicket. Actually, here I should name it as electric vehicle because car dashboard is only upper portion. Electric vehicle. You can use two groups, one for this car and battery and another one for this. And here I will so this is full electric vehicle. The above portion before this electric vehicle back portion where it is showing battery and inverter, this is the car dashboard. Now here in this trace graph, we have to proceed for the this is XY graph, and similarly I need to put things for trace graph also. So first we will put the trace graph for the speed looking into this. So put a trace graph. So I will now minimize it a little bit. This is the trace graph. For trace graph, just click it and mention it. Speed, kilometer, hour. Then add the signals. And for signal, you have to again add this electric vehicle. Mechanical means this is speed in kilometer per hour. Okay. So this is already we have started. The button is clicked. Now for this trace graph portion, XY graph which we have taken. So this one is for torque into speed. This is torque into speed. So on x-axis we will take the speed. So again the speed which we are going to take, again it is in kilometer per hour, the same. So this is for the x-axis, and for the y-axis, we are going to take the machine electrical torque. Okay. So machine electrical torque we are going to take. I'll just speed this rate as 250 and okay, in this advanced setting, going to auto scale. So just change it. So otherwise it is make it from 0,
हवलकर सर गुड आफ्टरनून
0 and range it
हाँ
from
सर आपकी शीट बन गई है
300.
व्हाट्सएप से जब भी टाइम मिले आप सेंड कर दीजिए सर नहीं सर कंट्रोल सिस्टम
Then
कंट्रोल
for
सिस्टम
y-axis also make it from
हाँ बराबर
minus
बराबर
300
सर एक
to
बात बताइए
900.
ये सब्जेक्ट में हमारे पास जो शीट आई है उसमें सुहेल सर का नाम है
And time window seconds it is 50.
अच्छा
Right now it is showing in circular. As you can convert it, we want the line graph, so it will show like this. So press it okay. Then for the second graph, it is power into speed. So for this, when I will toggle it full screen, so you can see it like that, power into speed. And for this again, for the x-axis, we need to have
वालेकुम अस्सलाम बोला
changing this rate as 250 and so that we can show it fast.
सर डीवीएम आया
So
मुझे
speed kilometer per hour we will be requiring.
डीएम आया हाँ तू एक काम कर फिलहाल पीएम ज्वाइन कर ले मैं बताता हूँ तेरे को हाँ नहीं फिलहाल कुछ मत लिख बट मेरे को अभी ना यहाँ पे मैसेज डाल दे करके कि सर मुझे ईमेल पीएम का आया है बट आई वांट पीएम करके ऐसा मैसेज इस पे लिख के रख दे मेरे को याद रख
And for this we
हाँ
require the
मैसेज लिख के
power.
रख मैं करता हूँ आगे
So it is again electric vehicle power P underscore kilowatt.
इधर ही देख सर प्लीज सर मैं इधर देखिए सर देखिए सर वाला पीएम का इधर हाँ
Again here in advanced setting,
03 नोट्स करने सर
make the changes similar manner.
दिसंबर 2020
Start it from click it on auto scale and start it from 0. And 300.
सुहेल सर का नाम आता है हमारे पास में नहीं नहीं वो उनकी गलती है उसको मैसेज में लिख दिया मैंने चेक किया इसका लेकिन इसका
Then for y-axis, you can show it from minus 90.
ये क्या हो गया कि मेरे को एक काम
This
सामने
is 0
दूसरा कोई काम सामने नहीं
and
है मैं
till
ऐसे
360.
मैं ऐसे होगा देखो दिसंबर 11 कैसे 11
50 seconds,
आज आपने पेपर नहीं देखी
9.
लास्ट डेट
Okay.
दिसंबर 2021 मैंने मेल इंस्टेंट सुहेल सर को पर्सनली डाला था मतलब कोई बात नहीं सुहेल सर के बारे में
Now rest of the portion which was shown as into the status, we can take the same display graph for that, but that's not too much important. What we want to see is the result. Now we are ready to see the result. Even you can add the capture and scope for seeing the results of these meter currents and others. I'll just toggle it full screen and we'll just check the main result which we wanted to see. So that has been designed as of now. So I'll save the panel
मार्क्स कंपेयर करना है
and save the model settings as well. Yes. Okay, I have to stop. So I will not stop right now.
एआईटीसी के बच्चे ने कॉल
Toggle it full
सर
screen.
कोई अलग नहीं 70 नहीं छोड़ दो ना सर उसमें क्या है मैं अगर कुछ लगा कल तो मैं बोलूँगा मेरा मेल नहीं था वो चेक करो परफेक्ट हाँ वो हमारे थॉय सर रहते हैं फिर आपके हाँ सर थे वो लोग आके एकदम ये शिफ्ट टू है ना हाँ शिफ्ट टू लिखना नहीं है नहीं यहाँ पे लिखना है सर
This
इधर
is
सॉरी इस पे लिखना है शिफ्ट
my as it is in
अंकुर सर है क्या
this is the speed, this is the torque graph, and this is the battery. Now we have already started. Now we will provide this speed to this particular vehicle. So just drag on, just look into the real time as it is working in the real time. So here the first we have clicked on the start. This is a start. Now we will accelerate the speed. So we will accelerate the speed up till 50. I'm going to accelerate near about 50. So see the motor RPM, and it is, so battery is discharging because it is giving power to this drive. Okay. So now you can see the torque and power graph now, how fast it is going on rather than vertical mode. Are you all able to look it properly? Am I audible?
Yes, madam, you're audible.
Okay. So now, as the regenerative power has also started it very slow as we provided the condition. So as this button blinked it, so now this you can see this is giving means the reverse it is going on, means this is also giving power to this battery. Now this is giving a power to the grid, means this is right now it is going on grid to vehicle, and as this regeneration button will blink on, see as this will blink, so this will vehicle is given back power to this battery. Now I'll again speed. Now can you see the distance? It is also whatever it is covering, it is showing in. So now I will speed, making it slow till 19. So after a few minutes, now see this the regenerating power button will blink after a few minutes.
मग मी नंतर म्हटलं की ठीक आहे चला आपल्याला डायरेक्ट करता येईल सोल्युशन ते माझ्या डोक्यात एवढं इझी होऊन गेलं की मला असं वाटलं की करून 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 ते राहिलं तसंच आणि आता सगळं झालं की आणि करून टाकलं मग मी मेल केला.
So as this will blink, can you see now this has blinked? Now we are getting back to the vehicle to grid. This arrow, the code which we have used. Now I will apply the brakes. So the speed will now become to 0. We will wait for the speed. So see the speed has become 0. Now it is becoming standby mode. Only the part we did not created about the status, because it will again take a few more means 15 to 20 minutes. So that time we are not having. But this was the full thing which we wanted to show. And here you can see the graph also. Now I will show you with that also, with the real model also the things. This is what we designed. And now I'll toggle it full screen. Only the status portion and the charger disconnected widget we didn't made it. So here you can see this electric torque and average consumption total, whatever the important components we designed it with. Now I will show, I'll just stop this simulation and save this model settings also. File. Save. Yes. Panel also it is saved. Now I'll close this panel. Now I will, the example what is happening, that also I will show you in real time, the status part which we have not created for that. So this is our example model. We'll compile. And it is loading. The same manner we have to put the text display for the status also, as it is showing. Till it is loading, if anybody is having questions, so please ask. Because I only need to show the status for this UPS and connected to grid, that part. So whatever results we were given in virtual mode, the same result we are getting in this real-time mode also. Only the difference is that the speed has increased. This is the difference. In real-time simulation, when we are working, it was just it has increased the speed as we are processing the plant by one processor and the controller by another processor. So we use two processors. That's why the speed is increased. And if anybody has having query, they can ask. The model is loading up. So this is the SCADA panel for it. Now it has been loaded. Now this portion we have observed. Now we need to see this portion. So before connecting to the charger, we need to stop our vehicle. So see, this is the operation mode. In this operation mode, when I have started with this EV charging, so it will be soon connected to the grid. See, now the supply is going from grid to vehicle. Now from here I can disconnect the charger, disconnected the charger. Now vehicle to grid supply you can see. Now the supply is going from vehicle to grid. And when I will change this UPS mode, you will get this LED. The same text display box is copied here, only we changed this portion. I'll just show you. We have used the charging status here. So only this line we have changed, means enabled. Here we have enabled this charging inverter controller, and this you can read it from digital signal. Okay, and we change the arrows. Nothing else we have done. Only enabling signal is changed in the text display and the arrow and the colors here for the status. And the status, for the status we have taken a group widget. Here you can initialize it. Otherwise, don't initialize it. Directly import the signals from where it is asking, like connected to grid. So you can directly go to the red digital signal, and with that you can upload these signals as we have done in our this dashboard and this vehicle panels. Then in operation presets also we have used this group widgets. Again we have used this buttons. So for this buttons for EV charging, I will show you all these values are SCADA input values. So you can fetch go to this SCADA input values. And all these values we need to feed it. So just insert all these values. Like we inserted right now, like for P reference, for Q reference, only the reference values mode 1, 0. And here you can see the power, it is 1 minus 150 power reference, then Q reference is 0. So these values we have to make a note of it, and the same signals will be inserted. For this vehicle to grid, the same, only what we changed, now P reference is 150. This is the change here in the reference value. And in UPS mode, we made it as 0 and mode also is 0, and Q reference is 0. Only this is the difference, and the same code we have inserted from API of this SCADA inputs. So I am done today with this and just closing this session from Typhoon Hill. And if you require any help, so you can just ping us on this ID as of now, and later on when we will update. So from my mail ID, you will receive the mail as well. corps.com. Till then, if anybody is having query, just do ask. Anything else which you didn't understood regarding the widget section if you were performing? The host team. Shraddha ma'am, Sameer sir, are you available?
Hello, madam. Yes, we are there.
Sir, I have done. If there is any questions, they can ask. All the important panels which we needed to observe, I have shown you. Have you seen it, sir, or not?
Yes, madam. We have seen that panels, and I think there is
And
no question
also we
from
were
the
working.
participants.
Yeah, we
Okay.
yes.
So,
So real time simulation also you have seen.
yes, madam. We have seen all these simulations. Okay.
Yes.
Okay. So,
Okay, sir.
stop here if any participants have no questions. So then we can stop here because we have only 20 minutes left for our afternoon session.
Yes, sir. Sorry for that. I regret
No,
for
no,
that
no.
time because earlier in the morning I opened my laptop. It was working fine. I don't know what happened. The screen gone immediately.
Okay, no issue, madam. No issue.
Uh, so that was a technical problem from my side. I do regret from my side. I just means I don't know that what I was feeling at that time. So half an hour took there.
Okay, no, madam. No issue. Thank you, madam, for your support. And I request you to be kindly present in today's validatory program that is going to be held at 4:30 p.m. sharp. So be present in that validation program with your team so that we can motivate you further. So please, madam, we will directly meet at 4:30 in validation program. Okay.
And this PSIM software program will start this at 2:30.
Yes, madam. Yes. So participants kindly note that I have shared the PSIM software link in your WhatsApp group. So kindly go through that and install that. We have Dr. Manaswi Suraj sir at 2:30 with us, and he is going to take the hands-on session on the electric vehicle charger design. So it is also a one uh, good session. So kindly all participants be present there. We will take a 20 minutes break here. Okay. And we will again directly meet to the 2:30 p.m. Thank you very much. Thank you, madam.
Thank you, sir, and thank you the whole host team. I
Thank
request Dr. Saurav and Dr. Salim, please be present. And if Azul is also present, so kindly be present
Yes,
on
ma'am.
the same
Okay,
link.
ma'am. Okay.
I may be available or not, but you all are be free available. If I will be free, then I will be available on that same day.
Sure, ma'am.
Yes, so the session is over. Participant can leave now. Be on time and join session at 2:30 sharp.
फास्टिंग बंद नहीं कर रहा हूँ मैं। थैंक यू भाई, थैंक यू वेरी मच। अभी हमारे खिलाड़ी नंबर 1 आएंगे, रेडी करके रखते हैं। नमाज पढ़ के लो, आके बैठेंगे, तमीज से रहे, बोलो नमाज के लिए गए, बैठ जाओ सर 5 मिनट। चलो आदि बच्चे क्या परेशान करते हैं। चलो चलो जाएगा, फिर इधर से उधर लेना पड़ेगा ना, डबल काम हो जाएगा। हाँ मैम सब चालू है। बैठा सर,
बैठिए बैठिए बैठिए।
सर आपको एक्सेस करना है ना?
कुछ नहीं, क्या डाल देता हूँ, हमारा मेल ओपन कीजिए। शेफी.मुजावर
ये भी बोल देंगे क्या? कहाँ जाऊँ सर? 23 है ना?
27 किधर है 27?
ये रहा सर।
ये नहीं वो नहीं 27 12 ये खोलो, ओपन करो। यस, ये देखिए पूरा करके रखा मेरा है ऐसे।
2 मिनट का सर। 7 + 1 8 है ना ये?
हाँ अभी दूसरी शीट बनाना पड़ेगा ना उसकी।
हाँ उसकी शुरुआत।
सेकंड शिफ्ट का है ना बच्चे?
हाँ सर। वन डाल दो।
ठीक है
सर ये बच्चा पास है ना?
हाँ पास है। देखो देखो पूरा लास्ट में ग्रैंड टोटल है देखो।
हाँ 34। क्योंकि सर फेल कोई हुआ नहीं है।
नहीं उसने वो अपलोड ही नहीं किया उसने।
हाँ वो बढ़िया सर। वो
एक अपलोड नहीं किया उसने जो एमसीक्यू है, वो बाद में अपलोड किया मुझे 2 दिन के बाद, बोलते कि सर मैंने भूल गया था। अब 2 दिन के पास तेरे पास इस तरह बोला मैं, बरोबर ना?
बराबर सर। क्वेश्चन 2 ABCDEF। क्वेश्चन 2 ABCDEF। ओके क्लियर।
पूरा इसलिए ना कॉपी करके
ABC
DEF है उसको भी
DEF है वो। अच्छा
इसको भी एफ दे दो वहाँ पे, ऐड कर दो।
ऐड करना पड़ेगा।
क्योंकि 4 में से 6 में से 4 सॉल्व करना है। 5 और 20 5 और 20 ऐसा है वो।
ABC
क्वेश्चन 3 ABCDE and F। माशाल्लाह। ओके अभी यहाँ पे क्वेश्चन
ABC है
नंबर
ना
4 में
सर?
ABC 3 में से कोई भी
हाँ
2 सॉल्व करना है। क्वेश्चन ABC
फिनिश किया ना?
ये करनी है। ABC क्वेश्चन ABC
इसमें कुछ नहीं 49 टोटल।
49 आगे 49 is
49 आ रहा है इसमें।
yes very good। ये नहीं नीचे का एक एक्स्ट्रा है।
हाँ
क्वेश्चन नंबर 3 क्वेश्चन नंबर 3 yes very good। डायरेक्ट मार्कशीट बनने की अभी
हाँ सर ट्राइब मार्कशीट बना रहा हूँ।
अभी इसको और कोई चेक करने वाला है क्या?
नहीं सर आप और मैं ही साइन
बस।
करने के बदला में सर।
ओके
36 और 60 30
इसमें एक एक्स्ट्रा था तो यहाँ पे मेरा नहीं है इधर, ये एक्स्ट्रा है ना। हाँ नहीं बराबर, एक मिनट 36 के होंगे, देखो इधर आगे, हाँ यहाँ पे देखो, यहाँ पे देखो, हाँ यहाँ पे एक एक्स्ट्रा है
ये एक्स्ट्रा है क्या सर?
हाँ एक्स्ट्रा है, वो कौन से भी 4 है ना उसमें के
5, ये एक्स्ट्रा है ना पक्का सर?
हाँ देखो ना यहाँ पे देखो, 5 5 सबसे ज़्यादा कौन है?
नहीं ठीक है सर, मैं वो समझ गया।
यस
34 हो गया।
पास हुआ ना सर ये?
हाँ पास है सर, 29 इज पास। तो 2 ही कर दिया सर, आपका
तो
34
जीरो
आ
नहीं
गया।
आएगा यहाँ पे, तो डैश होगा ना, क्योंकि पेपर ही सबमिट नहीं किया ना उसने, वो जीरो मतलब कुछ वहाँ पे बरोबर ना?
डैश है सर, बराबर डैश
बरोबर ना?
हाँ बराबर सर।
क्योंकि सवाल ही से नहीं किया। क्या देख रहे हो?
तो डैश डाल दिया सर, अटेम्प्टेड नहीं है उन सबको डैश।
नाम भी देखो उनके,
नाम
उधर ऊपर है देखिए, और ये सीरियल वाइज नहीं है ये।
अच्छा 1 के 2 नाम है सर।
बरोबर 1 के एक CS का है ना, वो CS नहीं लेता वहाँ पे वो।
अच्छा तो फिर कौन सा वाला 1 को इसमें से नाम?
ये
आफ्ताब
सारे
है।
आफ्ताब।
ठीक है सर।
I request participants to install the PSIM software on their laptop. I have shared the link in WhatsApp group. So kindly please check and let me know whether all of you have installed that PSIM or not.
फिर भी चेक करता हूँ मैं इसमें लैपटॉप में, बरोबर ना?
प्लीज सर, बाय ऑल मींस।
कैसा है, गड़बड़ नहीं होना इसमें।
सर एक्स्ट्रा सिर्फ एक ही में था ना, और किसी वाले में भी एक्स्ट्रा नहीं है ना?
है होगा, देखो है वहाँ पे।
49 60 60 49 61 60 49 61 60 49 57 49 आना है इसका।
हाँ वहाँ पे देखिए,
57 34 60 57 34 60 और ये 55 और ये 55 सही है सर।
खान सुहेल अनवर, CS खान सुहेल अनवर,
सुहेल खान लिखा है सर।
खान सुहेल SOHAIL अनवर, डालते हैं वहाँ पे, डालते हैं पूरा खान सुहेल SOHAIL अनवर।
सर ये इसका सब्जेक्ट का नाम क्या है?
ये मैकेनिक्स ऑफ सॉलिड, मैकेनिक्स
सर कोई शॉर्ट फॉर्म है इसका?
MOS
सेम 3।
सेम 3। हाँ और क्या है, कब हो गया है?
आज सबमिट हो रहा सर।
SHAFIMUJAWAR। हाँ ठीक है सर। हाँ सर आपको ये देखना है।
नाम तो सही आ गए। पहला एक नंबर क्या है?
अंसारी आफ्ताब
कैपिटल करो ना उसको सिलेक्शन करके पूरे।
सर ऐसा कुछ ये नहीं है।
अपर केस लेटर है ना उधर?
इसमें रहता है, वर्ड में रहता है।
रहने तो चलेगा क्या फिर?
हाँ चलेगा सर।
करेंगे उन्होंने बाद में वो लोग।
नो प्रॉब्लम।
हाँ
नो प्रॉब्लम। वर्ड में रहता सर, वो इसमें नहीं आ रहा, देखो ना साइज को है, कलर नहीं सर, अपर केस नहीं है, यही लिख के रहता हूँ, AL लिख के टू द बेस। ठीक है सर, यहाँ मेरा मतलब सब सेट है। आपको कुछ चेक करना है सर? आपकी भी मार्कशीट है इसके लिए।
ठीक है ठीक है ठीक है।
मार दो प्रिंट।
एक मिनट थोड़ा ये दिखाओ मुझे। मेरा वाला दिखाओ ना, एक प्रिंट ले लो ना मेरा वाला इधर का। ये पहला कितना है?
49
किसको है? 14 करो।
001 को है।
एक किलो क्या जरूरत नहीं ना? हाँ चेक करो, अभी क्रॉस चेक करते चलो। अच्छा इधर
सर 1 to 7 जो नंबर है 49 61 60, 49 61 60,
हाँ
फिर 49 56 4, 49 57 34,
ओके।
उसके बाद में है 60 और दूसरे पेज पे 55 आना है।
60 किसको है लास्ट में? महेश्वरी का?
007 को है सर।
महेश्वरी ठीक है। उसको लास्ट को 55 ना हो?
हाँ सर।
ओके बरोबर है। आए ना बरोबर? अभी एक्स्ट्रा हो गया ना उधर?
सब हो गया सर मेरी तरफ में, मतलब हमको तो इसको चाहिए नहीं।
ठीक है माशाल्लाह। चलो
प्रिंट करता बस।
वो अपर केस लेटर होना था तो बस हो जाता। क्या टाइप करना था?
नहीं सर
जरूरत
नहीं,
ना?
कोई बात नहीं, मैं को बस सेव कर दूँगा सर फाइल। शिफ्ट 1 एंड 2 सर, सी शिफ्ट 1 एंड 2 दोनों बनाया हुआ है।
ओके एम कैपिटल करो थोड़ा वहाँ पे। ना उसका नंबर ये है ना, उसका CES है ना?
हाँ
सेकंड
सर,
शिफ्ट वाले का।
CES
सेकंड शिफ्ट वाले का देखो।
CES 193001।
बरोबर 500 है नंबर। अस्सी क्रॉस नहीं कर पाया इस बार।
क्या सर?
80 क्रॉस नहीं कर पाया कोई, बोल रहा इस बार। पेपर बहुत लेंदी आया था। देखो पेपर इसका था कि कहने के इसका सॉल्यूशन बनाया मैंने।
श्रद्धा मैडम।
Yes, sir. Hello.
Madam, yes, madam, you are audible.
Okay. Sir, give me some 1 minute, 1-2 minutes to start.
फिगर वगैरह सब ये कलर में आते हैं। देखो दिखा मुझे तो पेपर देखा
हाँ शरीफ भाई,
कैसे कर लेते हो सर? हाँ कैसे बना? आपका बुक का स्कैन है क्या? हाँ मेरे बुक का स्कैन है ये। अच्छा बुक का स्कैन है, मतलब क्या एकदम नीट एंड टाइडी ऐसा लग रहा है, ऐसा किसी ने असाइनमेंट लिख के दिया होता ना सर, इम्प्रेस करने के लिए। मेरा हर एक पेपर ऐसा ही रहता सर मेरे। माशाल्लाह सर, मेरे नोट्स ऐसे ही रहते मेरे पूरे। हैंडराइटिंग सर, ये कलर में बहुत खूबसूरत लगता है। ऐसे यहाँ देखे तो समझ में नहीं आएगा तुमको, ब्लैक एंड वाइट में। मौसम सर, मौसम ज़्यादा ये सब मुंबई यूनिवर्सिटी को भेज दिया है। अच्छा हाँ,
Samir sir, am I audible?
Yes, yes, you are audible. Yes, madam. Yes, you are audible. You can start.
Yes, sir. Good afternoon, everyone present over here. I would like to introduce our resource person for the session, Dr. Manasvi Srivastava. Sir is present. Yes, sir. Samir sir. Yes, yes. Okay, thank you, sir. So welcome, sir. On behalf of EE-AIKTC and organizing committee, I am welcome you. So I would like to introduce participants about the resource person. So sir has completed his master from electrical and electronics engineering from Uttar Pradesh Technical University. Now Dr. APJ Abdul Kalam Technical University known as in 2012, and he has completed his master's in the electrical engineering from the GLA University, Mathura, and he has completed his PhD from Malavia National Institute of Technology, Jaipur, Rajasthan, India in April 21, and now he is serving as assistant professor in the Department of Electrical and Instrument Engineering, Thapar Institute of Engineering and Technology, Thapar University, Patiala, Punjab. So, sir has so much research experience, and their research interest is in fundamentals that investigation on onboard charger topologies for transportation applications, modeling of IoT-based smart transportations. So on his account, there are 2 patents, a full bridge DC-DC converter with voltage spike suppression for EV battery charging, and another is a single phase transformer lace boosting inverter with leakage current elimination for photovoltaic applications. And he has published many papers in reputed journals, almost 11 papers and conferences in national and international conferences. So thank you, sir. I would like to hand over this session to you. And you can share your thoughts and experience and PPTs with us. Welcome, sir.
Thank you so much, ma'am. And I'm sorry that I have joined late because my HOD called me due to some emergency
no
meeting.
problem. The previous session just 10 to 20 minutes before we have finished. So it is okay, sir. No problem.
Thank you so much. So in this session,
Yes,
I am just talking about. Shall I start, ma'am?
Yes, sir. Your screen is visible.
Yeah. So in today's session, we will start on the discussion is totally based on the fundamental discussion that we all are having. Electric vehicle chargers. So I have the DC-DC side is very prominent for charging the batteries, and it plays a key role over there because we don't know what kind of battery characteristics that we are having. So to match the profile of the battery characteristics, we have to design DC-DC converter in that particular way. So I briefly start with the fundamental units, how we started basically, because I have started my research from the scratch. But I even don't know how to make hardwares when I joined the. So we'll start with the basic discussion and what are the different uh, aids which are provided by the government of India, so that if we can develop something in our institute, so we will go through the on the real time basis. So this is the overview of my presentation, that I will cover the overall Indian scenario. What are the barriers in electric vehicles in different sectors? What are the initiatives taken by the Indian government? Then I will just discriminate what is the difference between onboard and off-board chargers. What are the standards for the electric vehicles? Because we have to follow particular standards while designing the hardware or the prototypes. What is the impact of the basic unit of the power electronics? That is the selection. How the DC-DC converter topologies have evolved. Then we will do some basic simulation on the PSIM, that is the power simulation tool. And then I will give a brief about what I have done PhD and then my contact. So this is the Indian scenario. Basically, if you just look over the map of India, there are so many dots I have placed according to the source, according to the Niti Aayog report that I have studied. So in the north zone, we will see over there are so many red dots. It means the air is polluted in such a way that our respiratory illness will prolong. If you go through this eastern belt, here you just see there is a combination of yellow and green dot. Yellow means breathing discomfort for the people with the lungs, asthma and the heart disease. And green dot means the air is a bit fresh. You can just spend your life over there where there are green dots. And in this western zone, you can see orange dot. It means the breathing discomfort to most of the people on prolonged exposure. So Mumbai is being lying on this belt. So you have to focus more on your environment, right? And Punjab is almost here. So I'm just sitting in the yellow zone. So my breathing discomfort is a bit lesser than you, according to the report of Niti Aayog, right? So these are the different barriers in different sector of the electric vehicles. And so I have prepared one wheel over here, according to the reports that we have studied. So it is just like IPTM. It means the infrastructure barrier, policy barrier, technical barrier, and the market barrier. So you can start from anywhere, as we are related to the technical field. So we have to, look for the technical barriers that come into our path. So it is the battery efficiency, because we have to purchase the cells from either from Chile or from the China. What is the EV driving range? Because we are not the manufacturing of the motors. So we have to take care of that. Battery charging time, yes, you can just reduce the battery charging time by modifying the topologies or modifying the charges that you are having, or the technology that is being evolving in India. The safety concern, yes, because battery is an explosive load. So we are concerned about the safety. And last but not the least, environmental impact. Because if you throw out the battery, it will definitely going to give damage to the environment, because it is not environment friendly. So these are the different initiatives taken by the government of India: Make in India, Digital India, FAME, that is the faster adoption and manufacturing of electric vehicles, Green Mobility Fund, and Smart City Mission. So if you cover the Smart City Mission, all four above things, the initiative taken by India, government of India, has been covered out. Because in smart cities, digitalization is playing a more prominent part. You must have electric vehicles. You must have the IoTs, IOVs, or IoT, Internet of Everything. And if you have all these things, it means you are supporting the Green Mobility Fund. So if you are supporting, or if you are associated with the Smart City Mission, you are almost taking care of all the initiative that is being taken by the government of India for this electric vehicle phase. So this is one of the picture from my paper, emphasis of switch selection for electric vehicle battery chargers. So this is a car, this is the vehicle, and we have two chargers. One is the onboard charger, which is mounted on the vehicle. Other is the off-board charger, or we can say it the fast charger. Okay, so what is the difference between onboard charger and the fast charger or the off-board charger? Let me clear you one thing. Off-board charger may be planted outside, because if I'm talking about the car, right, you can mount that onboard charger on the vehicle, whereas if I'm talking about the e-rickshaws, you can't mount that onboard charger on the rickshaws, because unnecessarily the load of that rickshaw will increase out, and it will increase so many things like the cost and all those things, right? So we can't mount the onboard charger for the rickshaws or e-rickshaws on their body, but yeah, for vehicles you can mount on the bonnet of that car. It is also known as the AC charger, whereas off-board charger is known as DC charger, because AC unit is being absent over here. It is having the limited power rating. One clause is being passed by the globally that for manufacturing the chargers, you can follow any standard. Although India having the Bharat standards, but star mark is there, you can follow UL standard. You can follow SAE standard. You can follow. Just talking about the batteries and their chargers. That is the thing which is actually lagging. And in DC fast chargers, what happens? Its rating is a bit high, and you can't mount it on the vehicle. There are some standards. When we discuss the standards, you will definitely find out what is the difference between the onboard charger and the off-board chargers. So they're both having the different ratings. According to the ratings, we just create the difference between them. So if I zoom it out, the onboard chargers, some basic units is being evolved that you are seeing over here with the help of this plug. Supplies coming from the grid. It is just going into the EMI filter.
Sir.
Yes.
That problem is being there. So yeah. So it is the EMI filter. Just whatever the signal is being coming out, you have to filter out the voltage and current waveforms or the supply that is being coming out to you. Then the diode bridge rectifier is there. And then the interleaf PFC stage, which just improve your power factor correction. Then you have DC-DC converter, then output filter, and then it is going to your battery, right? So the full bridge DC-DC converter or the DC-DC stage is being, play a prominent role in that to match the characteristics of or to match the profile of the battery. You can match them with the help of the DC-DC converter. Or if you are going with a closed loop, then these are some auxiliary flyback converters, PFC control unit, and the DC-DC controller unit. You can put it out for making closed loop. So these are in fact, three basic units. rectifier, PFC stage, or AC to DC stage, or DC to DC stage with the power factor correction, which is going giving supply to the battery. Now, this is the standard that I have followed during my PhD. It is the standard for electric vehicle, that is SAE, Society of Automotive Engineers, has been classified level 1, 2, and 3 charging units or the charging levels for making the chargers. Level 1 and 2, these are known as the AC levels, and these are associated with the onboard chargers. So you can say from 1.08 kilowatt to 14.4 kilowatt, less than or equals to, you can just make or give the ratings to your onboard charger. And above that, up to 240 kilowatts, we are having the off-board charger. From here, you can see that the rating of the current is very much high. It is 200 amperes, 200 amperes, 80 amperes, which is, a very huge amount of current, and this much of width of the wire or cable you need to give supply to the vehicle while giving this much of amount. So they are come under the DC level 1, 2, and 3, and up to 3.3 kilowatts it is come up to AC level 2, and from 1.08 to 1.44 they are the AC level 1. So these are the ratings which are decided by the SAE. You can follow them, or you can follow any of the standard that suits you. But 1 kilowatt approximately, it is like the minimum rating for the onboard charger. So for deciding the impact of the switch selection, as you know, we are using here for DC-DC converters, we are using MOSFETs because for high frequency, I need them. And as technology is being evolving, you can see, first of all, we are having the silicon switch, then silicon carbide. Yeah, any questions? Yeah. So silicon MOSFETs we are having, then we have silicon carbides. Now we are having GaN switches, which is the gallium nitride switches. So how we are selecting these switches? So while I was working, we are having switches of 2 switches, silicon switch and silicon carbide switch. So just I compare the 3 switches, 1 silicon switch and 2 silicon carbide switches. I have just randomly taken parameters in that, and these parameters are shown in table number 1 on your screen that you are seeing over here. That input is 400 volt, output is 54 volt. It is a step down transformer, the boost converter that we are having. Output is 20 amperes, and the frequency that I have taken, it was 100 kilohertz. Transfer ratios 14:3, and all other components in the full bridge converter. 3 switches I have taken. IRFP 460, it is silicon switch. IXFN 64N60P, it is silicon carbide switch. And IPP 65R045C7, it is also silicon carbide switch. So why I am comparing it, right? So while you are dealing with the real-time implementation of any electrical unit, at the end, it is associated with the economics, right? So if you are dealing with the economics, then you have to take care of the price that is being associated with the prototype that you are making, basically, right? So when I have seen the impact of these 3 switches, as you know, the power is being increasing up to 1 kilowatt. We have tested. SI1 is IRFP 460, SC2 is the IXFN series, and SC3 is IPP, right? So here in the graph that I have not written the whole name. So you are seeing over here from this graph and from this efficiency graph, as the power is increasing, the efficiency of IPP 65R045C7 is increasing, right? If you compare the efficiency of all these 3, then the efficiency of IPP series having the more efficiency at each power level from 100 watts to 1000 watts. Okay. Similar things is being plotted here in the pie chart. So what we have concluded, that IXFN IPP is the cheapest switch that we are having. IRFP 460 is the cheapest switch that we are having. Its cost is all around the 70 rupees. Of single switch costs about the 17 rupees. IXFN 64 and 60P, its cost around the 1500 rupees. And IPP 65R04567, it costs around 650 to 700 rupees. But as time progresses, we are able to manage the heat with the IPP series, right? So the conclusion is that for the converters that we will make, we will use the IPP series in that. Why? Because we are having it in the optimized rate in comparison of these three switches that we have compared, and we can manage the heat. Why? Because the drain to source resistance of IPP is 0.046 ohm or 46 milliohm, whereas the IXFN having the 96 milliohm drain to source on resistance, and IRFP 460 is having 270 milliohm, means 0.27 ohm RDS on. It means what? When you switch is on, then I square R losses have increased. So conduction loss is more in IRFP 460. It is more in IXFN series, but it is not as they are in both these switches. It means IPP series having the least conduction loss when its switch is operating. So this is the conclusion of the selection of why we will emphasis on the switch selection. Now we will jump into the DC-DC converter topology, how it get involved and what are its type. So broadly, the converters are classified into three categories, or the three charging categories. It is the unidirectional chargers, bidirectional charger, and wireless charger. So in unidirectional charger, the power is flow from source to load, and these are the dedicated chargers. You can just charge the vehicle with the help of them. Bidirectional charger, we are mostly used with grid connected vehicles so that you can take power from the grid and you can inject power from vehicle to grid also. So wireless chargers are classified into the two categories. First is the static charging and other is the dynamic charging. So static charging is like that you are having the transmitter coil at your garage. When you came from the office, you just park your car. Over it, it will automatically get recharged. Dynamic charging associated with when your vehicle is moving, while moving, it will get charged. It means for heavy vehicles like trucks, like bus, they need dynamic charging because in zebra crossing in the Europe, they are having the static coils over there and they have particular speed. They have written the particular speed that at this particular speed or at this particular condition, your vehicle will get charged from this much percentage to this much percentage. So at bus stop, at zebra crossing, they are putting some coils for some particular resistance, and when the bus or the car is moving over it, then they get charged. So now for the PSIM session, I have taken a basic unit of the converters. If BTech students are over here, so they can just go through their basic converter topology. That is the buck converter. It is the basic converter, and all other converters are evolved from the three converters: buck converter, boost converter, and buck boost converter. No other converter having any other basic fundamental units except these three basic units. So these are the following assumptions that I have taken, and everybody will take while doing the analysis of any converter. The circuit is operating in the steady state. the capacitor at the output filter, the capacitor is large enough so that it can able to maintain the constant output at the voltage. Switching period is T, close time is dt, and off time is 1 minus dt, and all the components are ideal. So D is the duty cycle. Duty cycle is T on divided by total T. T on means at the time for which your switch is on, divided by on time plus off time. So here you can see basic buck converter unit. Those who gone through this, they do not need to more worried about it, because in classroom programs, this is the converter which which is taught by the zeal, because it is the basic converter for the starting of power electronics. So first of all, we have an input over here, the input DC supply, a switch. We can't put a switch in series with the inductor. That's why we have put diode over here, and one capacitor for maintaining the constant voltage across the load. When your switch is closed, this inductor will get charged and current through the inductor is increasing, and the voltage across this VL is Vs minus V0. When you apply the KVL over here, you will get this. When your switch is off, the direction of the current in the inductor will not change instantaneously. So it will flow in this direction, but your capacitor, which was fully charged, is now start discharging, right? In this fashion. Current is discharging in this fashion. And the current in inductor also is started decreasing. Then the voltage across VL is minus V0. And this is how things are working for the buck converter. So whatever the voltage you are getting over here, output, it is a buck converter, means it is buck converter. It means it is a step down converter. Boost converter, like the boost is secret of my energy, Stan Luker is saying in that ad when he was he was in the boost ad. Boost is secret of my energy. It means it is a step up. Buck means it is a step down. Buck boost means step up and step down. So this is the continuous conduction mode. If L is discharged before reaching to the second cycle, it is discontinuous conduction mode. So these are the two modes which are associated with all the converters that you are having. So if we are going into the mathematics, so when your switch is closed, L di by dt equals to Vs minus V0, I is closed and open. When you add both the currents, because for a whole cycle current in the inductor is 0, then you will get one expression. This is V0 equals to D times of Vs, right? For finding minimum and maximum current, this is the maximum current of the inductor, and this is the minimum current, and this is the I0 or the I average. So if you add delta IL by 2 in IR or I average, you will get the maximum current, and if you subtract it, you will get the minimum current. So same thing is there, it's a plus minus, so you will get the minimum and maximum current over here, and these are the expressions that you are getting over here, right? So for finding the boundary between the continuous and discontinuous mode, if you make minimum current equals to 0, then you will get the expression for the L. In that, you will find the boundary between them. It means if you take the value of L lesser than whatever you are calculating for I min equals to 0, you come into the discontinuous mode zone. And if you take 1.25 times more L, what is your I min, right? Then you will go on into the continuous conduction mode. In similar fashion, by applying the conservation of charge, you will get the expression for this capacitor. Sorry. So there's one design example we have taken. That is the example we have framed as one of the client in our startup has came out, and he is having some particular loads, and he has to design a buck converter for that. So to design a buck converter, this is a kind of a problem that we will simulate in the PSIM. So I request you all, those who have installed PSIM, kindly first solve this problem, and just for the 2 minutes I will give you, and open your PSIM. So we have to design a buck converter to produce an output voltage of 18 volt across 10 ohm load resistor. The output ripple must not exceed 0.5%. The DC supply is 48 volt. Designed for continuous inductor current, it means it is continuous conduction mode. Specify the duty ratio, that is the duty cycle. The switching frequency, which is considered to be the 40 kilohertz given in the question. The values of the inductor, capacitor, the peak voltage rating of each device, and the RMS current in the inductor and capacitor. You have to assume all ideal components, right?
तब इसके बाद जा रहा था कुछ तो लेके इसने किसकी सुना जो तेरी सुनेगा तू नहीं जाता ना बाप रे क्या बोला तो क्या नहीं तुमको सुनाया तो तेरा मूड अलग था उसका पता नहीं क्या था मैं करता ठीक है सर ओके मूड अलग था उसका बताइए
So I hope some of us has solved it. So this is the answer actually. Duty cycle comes out to be 0.375 is 78 micro Henry. So we have to multiply it 1.25 times because we have to come into continuous conduction mode. So we will have 97.5 micro Henry, and delta IL, the ripple is 2.8. The change in current is 2.88 ampere, maximum is 3.24 ampere, minimum is 0.36 ampere. LRMS is 1.98 amperes, and C is come out to be 100 microfarad. I hope you all have opened your SIM. Have you opened? Shall I start? Yeah. So this is the PSIM screen, right? So this is the PSIM screen that we all are having. And this is the menu bar where you can see the new, open, save, print, undo, redo, taskbars, wire connection. Yeah, zoom in, zoom out, everything over here. This is the run simulation and all those things. At the bottom of the screen, you will see there are some, components are giving over here, like ground, resistor, inductor, capacitor, diode, thyristor, so on and so forth, IGBT, MOSFET. So, as you all know, that we have buck converter. So what you have to do, you have to simulate, or you have this input supply. So put this one, just select it, put it by clicking your left this button of the mouse, then put it, then press escape. This is your VS. Make it as VS. Input is what? The question is written over here. Input is 18 volt. So make it as, I just put it here. Yeah. So it is 18 volts. So I just make it 18. If you want to display and all things will display over here. 18. Then what? We have to put one MOSFET. Either you take MOSFET from here, or you can go to elements, power, switches, and MOSFET. By right click, you just place it here. You can just rotate it, press escape. Then you have one diode. Again, you go to elements, power, switches, diode. You have diode. By right click, you just put it here, press escape. Then go to elements, power, RLC branch, inductor, put it here, escape. Then elements, power, switches, capacitor, right click, put it here. Or if you want to take resistor from here, just click it, rotate it, and put it here. Inductor current, you want to know, so you have to put ammeter in a series with it. And output voltage, so you have to connect voltage source over here. IL elements. Okay. So with the help of this wired connection, you just join them out. The simple connection that is being, done in the MATLAB. Take one ground, put it here. So this is RL, which is 10 ohm. This is C, its value is. So when you have to write the microfarad, you have to use U. For milli, you have to use M, not like MATLAB, right? E you can't use over here. So it is 100 micro. See out. Display all those things. This is L out. Its value is 97.5 microhenry. This is ILO. This is diode. Threshold voltage you will take 0.9 or 1.8 volts. So for the switch, you have to use this pulses. Now, how to give pulse? this is one of the most important question over here, how to give pulse. We will see. This is the pulse and we first connect it here. When you double click it, frequency we have to take kilohertz, so it is 40K. So D is here is duty cycle is what? V naught equals to D times of V input. It means D equals to V output divided by V input. It means output upon input. So output is 18, input is 48. Okay. So input is 48. So 18 divided by 48 is 0.375. 0.375. Okay. Then let me open the paint. I think I have some option over here also. Yeah. So D equals to V output upon V input. It is 18 divided by 48, which is 0.37. It means what? Here, whole cycle is assumed to be in 360 degrees. On time is 0.375. It means what? It is 37.5% of the whole cycle. It means 37.375 into 360. How much we are getting? We will get 135. So from 0 to 135, the switch will remain on, otherwise it will off. So what I have to put here? On state resistance 0.2. This 40K, number of points 2. One point is this 0, other points is 135. So it is 135. So in this fashion, you will give the pulse to your MOSFET. I hope this is clear to all of you. How we have given pulse. Is it okay or not? Shall we move further?
Yes, sir.
Yeah, okay. Thank you. So it is 0.27. As you open the data sheet of IRP 460, you will get it. On state resistance, the sold voltage is 0.9. You will take. Name is IRF P460. I will also show that how, we are not able to, we just directly call the MOSFETs in our system. And why we are using PSIM, let me clear you that why I am not going for the MATLAB, because MATLAB is taught in every college, right? And for closed loop system, MATLAB response is very, very good. Whereas if you are going for the open loop system or the topology verification kind of a thing, I must personally suggest you to go for PSIM, multisim, all those softwares. So this is all about this. Now I have to run it. As I run it, two things will come into the picture: IL0 and BP23. L0 we will see first. Open it. It is the initial transition, because initially transition will come out because when you just connect the new components, for once transition state will come, then it will go into the steady state, right? So it is the transient that is being coming out, and we will, what we have assumed in our assumption, steady state, in steady state condition, right? So whatever the values that are coming, they are coming in steady state condition, not for the transient state condition. Okay. Now I have to see the E. Yeah, it is 3.15. Okay. And what we have calculated, it is 3.24. Almost same. Okay, almost same. Then if you drag it to the lower point, it is 2 point. It is 2.13 E minus 1. It means it is 0.21. And whatever the minimum value we are taking, it is 0.36. So this is the error. This is the error. Why it is coming? Because we have put some of the practical parameters in it. And the same results you will find out when you go for the hardware. Now the RMS value, it is 1.98, it is 1.94, almost same. Okay, 1.98 we have calculated, 1.94 we are getting over here. What is the average value? Okay, so in this session, we will take and see the results. Now we will go for output voltage. Output voltage is 18 volt, and what we are getting over here, 17, approximately 17, because this waveform is dancing between 16.66 to 16.74. So the capacitor is big enough to maintain it almost at the 17 volts. So we are not getting 18 volt, we are getting 17 volts over here. So this kind of a fluctuation you will find out in this PSIM. Whereas for in the MATLAB, if you not put the I'm sorry, just a minute. Non-ideal parameters, you will not get that. Okay, so this is the difference, that what is the difference between when we are calculating the parameters and when we are simulating the parameters, and one error will come out when you implement the parameters, when you implement your hardware, right? So these are the errors will come out. So from calculation to hardware, your error must not exceed more than 30%. Okay. So those who are simulating, and if they are having any problem, they just ask me. Maybe one problem you will get, if you have not put that clock, your simulation will not run out. So you just go to the simulation and simulation control and just put this clock and close this box and just simply just run your simulation over here. Maybe you feel that I am a bit fast on the simulation, or just arranging and just putting and just connecting the elements. And if you are not able to do so, please kindly ask, I'll share your screen so that I can just help you out in that. Anybody who is simulating or having any doubts or any problems that is being come out in your way?
Sir, how to design that? How to select the values of this gate driver circuit?
Okay, the gate driver circuit you want to ask? Yeah, okay. So you see when you open it, our duty cycle comes out to be 37.5%. Okay. So if you take 37.5% of 360, what will the value that will come out? 0.375 into 360. It is 135. See, duty cycle is T on divided by T. And this T is T on plus T off. Okay. So duty cycle formula for buck converter is V output upon V input. V output is 18. V input is 48. It is 0.375. It means this switch, the switch that we have taken in the buck converter is open for 37.5% of the whole duty cycle. Okay. So what happened? If you open it, frequency that you know, it is given in the question, it is 40 kilohertz. Okay. Or decided by you on what frequency, on what operating frequency you want to operate your converter. So it is 40 kilohertz. Now there are a number of points and switching points. Switching point is this PSIM thinks in a form of degrees. So 0 to 360 degrees. It is full cycle. And for 180 degree, it is half cycle. So 37.5% of 360 is 135 degree. You just multiply 0.375 into 360, you will get 135. So it means that that switch is open from 0 to 135. For rest of the time, it is closed. Then again, when the cycle proceeds, this will on here up to 135 degrees. So there are 2 points from 0 to 360 degrees. There are only 2 points, 0 and 135. So I have taken and 135, 2 switching points. These are 1, 2. So I have written 2 over here. Clear?
Okay, sir. Okay, sir. Okay.
Okay. Thank you. Any other doubts? So shall we move further?
Yes, sir.
So now, yeah. Okay. Now this is the thing that we have taken the ideal components and we have proceeded in that fashion. Now, what happened if I will incorporate the IRFP directly? Because this is the PSIM that is not the full version. So we are not having those switches like silicon carbide switches in it. So if you have the full version, then you will have all those switches. So just we see how we can incorporate those switches so that we can Just from the simulation, we will check the conduction and the switching loss. So elements, power, thermal module, IGBT, rotate them, and directly then connect it. Okay, we have connected it. So if you double click on it, you want to change color, you change it in the red. Okay. Come to the parameter. Switching frequency is 40. Okay. Do not change anything over here. Just go to the device. IRFP460 is there. Select it. All other parameters will automatically come out into the picture. Then which probe? There are 4 probes. So which probe is showing what? That you have to take care of that. Okay. So by taking care of that, if you don't know how to see which probe is doing this, just go to the help. Directly go to the help. And now see, probe 1, that is dot, is being shown over here. It is the conduction loss of the switch. Second is the switching loss of the switch. Third is the conduction loss of the diode. Fourth is the switching loss of the diode. So how we will connect them? We are connecting them with the help of the ammeter. Ammeter is here. You just rotate them. Connect it, connect it, connect it, connect it. Right? Then you join these two. Then again, connect, connect. Again, for total loss, you want one more ammeter. Connect, and then go to the ground. So it is the named E conduction of the switch. E switching of the switch. E conduction of diode. T switching of diode. E switch loss. These are I'm writing in such a way because when I run it, I have options to show each to analyze the each loss with these names, right? So these are the probes that I am naming actually. E diode loss, and this is the total power loss, right? Rest everything remains the same. If you want to change this diode, you can also go to the elements, power, switches, thermal module, go to the thermal module and go to the diode and the database, whatever the diode you want to use. Then simply I just run it. Now I see plenty of options are being done. I'm sorry. So total loss I will see, right? So this is the total power loss. Go to these things. Check over here. So P total is 3.37. 0.33 what? 0.33764668 watt is the loss. It means 337 milliwatt is being lost in this switch only, right? So there are other parameters also. So huge power is being lost over here. Now, if you want to see the individual loss, you will see the switching loss. Check it here. Similarly, you can check other losses. If you want to plot them, you can just go to the file, edit, copy to the clipboard, meta file format, go to the Word or whatever the things you are using and just paste it. You will have this, okay, for your reports and all those things. So any questions in that if we are using the thermal module, what is the difference? So this is the in the practical what you are getting, or if you will see what is the output over here, if just I zoom it out and check. So VP3 is 16.79, almost 17. So no problem in that. So this is how you can check and simulate your buck converter with the ideal parameters or with the practical parameters. Any doubt till now in this question? In this session, I mean, any doubt you are having, you are facing, because simply a problem, a real-time problem that I have, I just simulate it out. And if you want, you can just use the similar parameters and you can make your hardware and go through it. You will definitely get the same results over there. Or if you want to ask something which has not been covered by me, so please ask. The session is open to all. But if you are simulating or if you are stuck somewhere, just share your screen and ask me. Just I will try to solve your problem out. This is the question. This is the answer. These answers we are simulating with two types, with the ideal condition or in listed with the practical in the practical conditions. So two kind of results we will take. First is the output, input and output, and the variation in the current of the inductor. Then we have seen that how individually power of the switch can be determined with the help of this practical box.
अच्छा हाँ सुनो, वो आरती बख्शी है ना, आरती बख्शी का कुछ तो काम चल रहा है कॉलेज में, तो अगर वो नहीं बोलेगी तो उसकी जाके अदिति बोल देगी, नाम आरती का ही लो तो अदिति।
Yeah, I hope you have understand this piece. So now I would again jump to my presentation. Yeah. So this problem we have simulated with the help of PSIM. This is the core data sheet for making the inductors for transformers. These kind of things will come into the picture out. So I was and I am associated with the CSER lab at MNIT Jaipur, as I am working as assistant professor in Thapar Institute. But yeah, I am associated with a CSER lab as I am the head coordinator over there for the almost 4 years. So Smart Energy and Sustainable Research Lab has completed almost 5 crore rupees project, which was funded by DST, and still we are having almost 4 to 5 crore project in our lab. I was the part of the electric vehicle charger project, which was worth of 50.92 lakh rupees, as well as I am also the part of the MI off grid project, which is the mission innovation project, which was recently commissioned out in the Boothal village of Jaipur. It's worth around 300 lakhs of rupees. And now we are having 97 lakh rupees and 2 or 3 crore rupees project in the lab. More projects I have not covered out. So this is all about our lab. It was established by Dr. Arun Kumar Verma. He is my guide during PhD, and he's the assistant professor in electrical department at MNIT Jaipur. This lab was established by us in 2017. We have also incubated one company which was named EE-AIKTC Technologies Private Limited. His chief is Dr. Arun Kumar Verma. And we have developed electric cycles. Actually, we have converted normal cycle into the electric cycles. We have made UV sanitizers for the COVID warriors during phase 1 wave, right? And we have distributed among them free of cost. So this is about the EE-AIKTC. This is a cycle that we have converted. This is a normal cycle that we have converted into the E-cycle. This is the battery, and we have used the disc brakes and all those things. So its speed we have just limited to 25 kilometers per hour maximum, having disc brakes, 35 kilometers in a single charge. 2 hours it will take to charge. We will take only 2 hours to charge it fully. So these are some features of the chargers as well as the cycle that we have made. This is the ultraviolet clinical disinfection sanitizer that we have made. These are the normal rods that we are having in the college, then we have converted it into the ultraviolet clinical disinfection sanitizer boxes for the distribution during the phase 1 wave. This is my contact. If you want to contact me, these are the my email IDs. If you have any queries, you can just send it to me, or any queries regarding your PSIM or any simulation or the hardware prototype. You can just mail me. And if you want to see the updates, this is my personal website. So you can go through this website and just check what are the new things that is being done by me or that is being coming into the market. So I think that's all from my side. I was a bit, in tension that how I have covered that session in one time, but hopefully I have covered before 15 minutes that the time was allotted to me. So thank you so much for your patience. Or if you have any queries or any doubts, still you can ask me. We have enough time to discuss.
Sir, I would like to ask a question regarding the EV, this electrical vehicle charging stations. So while deployment or any infrastructure, when we think about planning and management of that EV charging stations, so what kind of calculations we have to do? Means as a basic point of view, means how we can relate how much power the EV charging station is required, or so is there any?
There are actually two things. So if you are thinking about the EV charging stations, then first one is if you're thinking about the placement of the charging stations or the location of the charging stations. Second thing is if you are thinking about the charging station or the structure of that charger, right? That is two different aspects. So if you are thinking about the placement of the charging or the location of the charges, that is the optimization problem. Yeah. If you are thinking about the structure of the chargers, there are so many things come into the picture, right? First one is the rating. Rating, I have told you, more than 14.4 kilowatts, you have to design your parameters, right? So for designing any converter, which is the DC-DC converter, you need input and output and the operating frequency. Rest things you will calculate at your own. Okay. For any converter, like the flyback you want to you use any other isolated converter, you use interleave converter. It totally depends on you, right? So for DC fast chargers, basically, usually we have used the buck configuration, which is the boost configuration, sorry, which is the current fed configuration, in which current is bit high. Okay. So this is the fundamental way of thinking. Rest, if your ratings is known, you can just go through it, or by increasing the frequency, the magnetic component size will get reduced, or if you are using the GAN switches, their losses will get reduced, its efficiency will get increased, and how you just economically optimize it. These all are the engineering parameters that you can just think of.
Yes.
But the of DC fast charging prototype making in laboratory for the researchers are a bit difficult.
Yes. Okay.
Any other thing you want to ask?
No, sir. Sir, I would like to ask that charger, depend on that charger types and the integration, the power quality issue will be there while integrating in the grid. So how we can means what will be the future scope for the chargers, so we can avoid this power quality issues.
Ma'am, if you see, industries are not using any of the chargers which is actually being proposed by the researchers, because they are using the resonant converters for the chargers. Okay. Resonant converters and totem pole converter design, right? Because these configuration is actually giving them 98 to 99.1% of efficiency. If you are having 99.1% efficiency, then what is the use of other things? Second thing, you have asked about the weaker grid integration of the charger. So bidirectional chargers having the more efficiency than the unidirectional and the wireless chargers, almost 97 to 98%. So the problem is that nowadays the power quality issue is being associated with the to mitigate the DC-DC converter stage. So chargers are proposed in such a way that you are proposing AC to DC converter with the power quality issue, so that you have not to use the DC-DC converter stage in that.
Okay.
And the integration is totally depend on your switching, because the grid we are using IGBTs, right? And for the converter, for the charger, we are using MOSFETs. So first of all, the operating frequency difference, then their synchronization difference. This will create the power quality issue. So like most of the people are dealing this problem on their own ways, right? But practically, integration of charger with the grid or grid to vehicle or vehicle to grid, they are giving us 97 to 98% of the efficiency.
Yes, sir. So any participants want to ask questions, you can put also chat box also. You can use it.
Similar question regarding to the power quality issues, but when we use a grid as well as there is a solar system, which is a DC system. So at that time, we will require more converters. Like there will be a converter from solar to the what we could say our charger, and from grid to the charger, as well as there will be storage systems for basically for backup whenever there is an problem in the grid, or if, during night times when we can't provide the solar power. So at that time, power quality issues we have to take care of that. No?
Yeah, you have to take care for that. You can propose the multifunction converter, single converter which is doing several things. You can refer Neerav Patel papers in that. He was a research scholar from MNIT. He has worked with me in that area. He has proposed the multifunctional converter, inverter and converter. The single converter is
what if we use
doing
split batteries? Split batteries means split batteries for storage system.
Your voice is actually breaking. Can you please repeat your question?
Yeah. So my question is,
split battery.
Split battery system, because I had read a research paper similar to that.
Yeah. This is I have also written the paper on the split batteries. Yeah, you can use split battery configuration. This is that is actually a very good concept in that. But the real-time implementation that we have done in the village, right, which was the first thing globally that we have done, we have not used any reference. We have not used any DC or something like that. We have stored the solar into the batteries, and then we have given it to 30 to 35 houses in the village, right? This is a real-time implementation that we have done under the mission innovation. So it is always not necessary to having the reference source.
Okay. Sir, can I get the link for that research papers?
I just give you my website address in the chat box link. You just go through it and you just go through it. It is Pawan Singh Tomar. He was the first author in the paper. I was the second, right? The split battery configuration. And one transaction also we have published in that for the split battery.
So is there any questions?
Sir, the second question I had is that, sir, are there any initiatives taken in converting the fuel stations, that is the petrol stations, into charging stations?
I'm not getting your question. Can you please repeat?
Yeah, sorry.
I think there's some problem. Internet problem is there.
Are there any initiatives taken to convert the petrol stations into charging stations? Because in near future we will require more number of charging stations, and the number of fuel stations already.
Charging stations are not like you are not converting the petrol stations into the charging stations. You have to implement them separately, or maybe they have some separate unit, but you can't replace them fully because the vehicles that is being launched in the market, they are not totally the EVs. They are like the hybrid kind of thing, hybrid electric vehicles. Within the most, because in 2018 EESL has launched was working on one car which the Tata Tiago launched by the Tata. So its intra-city range was 140 kilometers. Intercity range was 148 kilometers per charging. Because we don't have motors like Texas, we are not making the motors. That is our drawback. As well as we are not the manufacturer of the batteries. So these are
Tata,
the
sir,
drawbacks.
even Tata imports motors, because Nexon and that Nexon uses, Tata uses its own motor for Nexon.
The Nexon is recently they launched, na?
Recently only they launched. It's a mid-high range vehicle. It's around 15-16 lakhs. It's not for the middle class.
I was talking about the 2018 thing, because they are also dealing with the power quality issue as the DC-DC converter configurations. Charging problems was there, and the most prominent thing was all these vehicles are silent, very silent. You can just start and take away your vehicle. If anybody will take away your vehicle, even you don't have any idea about it, right? So range they may increase in these 3 years, but the power quality issue and the charging issues are also there. In that.
Okay, sir. Thank you.
Hi everybody. Assalamualaikum.
Sir, I think no questions from participants. So can we conclude the session?
Yeah, sure, ma'am. Thank you.
Yes. Thank you, sir. Thank you so much for gracing this occasion by your presence and sharing your knowledge with us. And shortly we are through the validation function. So be present, sir, for this if you are available.
Okay, thank you, sir.
Thank you, sir. Samir, sir. Samir, sir. Sheba, sir, is there?
Hello.
Hello, sir.
Hi, how are you?
I am fine, sir.
How's
So we will
everybody?
shortly start our session.
Yeah. Aren't you going to introduce me? Huh?
Yes, sir.
Are you not going to introduce me?
Sir, we will shortly start the session, and then Sheba sir is taking the handover from me.
Okay. What's the program? How many speeches? How many people are going to speak?
Sir, actually there are 74 participants. 45 something faculties are there, and rest are the students. Some students are final year students and some are the PhD scholar student. So I think this is afternoon session. That's why maybe the participants are showing less, but they will be shortly joining it.
How many total? You said 70.
74
Right now,
participants.
Okay.
Yes.
And how many people are going to? What is the program of valedictory?
It will be start, sir, at 4:15. But we will shortly end up, sir.
So what are we doing now?
Yes, sir.
Can we take the Shabbos? When is Shabbos coming?
Join, sir.
Call him online and check.
Okay, okay.
Nice. Shabazz, you are here?
Sir, he is joining in 1 minute only. Okay, sir.
Okay.
Yes, sir, he is in meeting.
Assalamu alaikum, sir.
Aslam, how are you?
I'm doing good, sir. How are you?
Okay.
Yes, sir.
क्या हो रहा है आज कितने लोग बोलने वाले हैं अभी में?
Sir, we have our HOD sir is one. Farade sir will be briefing the entire FDP, followed by the feedback of the participants. And
Okay.
then we will have address by director, sir. And then, the closing presidential address by you, sir. And then vote of thanks. Yes, sir.
कब शुरू हो रहा है?
The scheduled one is 4:50. We will start the recording.
Oh,
Yes, sir.
देखो क्या 4 बजे मेरा नंबर है. खैर और क्या खास खबर?
Yes, sir. Doing great. Yes, sir.
And you have decided to go on growing up.
Yeah. We are waiting for director sirs.
Dr. Priyanka Katoke can't be seen. Huh?
Hello.
हाँ जी.
Good evening, sir.
Good evening. How are you?
Fine, fine.
Nice seeing you. Thank you. अच्छा. Yeah, Sujata, tell me.
साइन द्या मॅडम, जेवून येतो पटापट मी पण खाली मग. ये उलटा 7 करके बा. जा रहा ना अभी इरफान के साथ बाइक पे. पीसी सब खाली यूपीएस बंद कर दो, ये बटन बंद मत करो. अरे बाबा नाम सामने जा रहा है.
Hello. 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 Can't hear.
Right. So with your due permission, Chairman, sir, can we start the valedictory program, sir?
Yeah, please.
All right, sir. Okay. So Assalamu alaikum and good evening, everyone. Welcome to the valedictory program of the 6 days National Faculty Development Program on development, modeling, and simulation of electric vehicle and its charging station using Typhoon Hill. The program is organized by Electrical Engineering Department of Anjuman-e-Islam's Kalseka Technical Campus, New Panvel. It was an amazing experience to have you all for the FDP, and we are sure that the learnings will benefit you in the upcoming timeline. I'm happy to welcome our Honorable Executive Chairman, Mr. Burhan Haris, sir, who is going to preside over this valedictory program. Joining soon, we will have our Honorable Director of EE-AIKTC, Dr. Abdul Razak.
I have already joined, sir.
Okay, so we also, we wish to welcome our director, sir, Dr. Abdul Razak Hanutagi. I wish also, to extend our warm greetings to all the resource persons who were, sharing their knowledge in this amazing FDP, starting with Dr. Ritula Thakur, Dr. Manas Vishwastha, Dr. Baba Saheb Chimaji Kharbas, Mr. Mohan Joshi, Mr. Ujjwal Vyas, Mrs. Khushbu Purwar, Dr. Salim Qureshi, Mr. Saurav Sahu, Mr. Fazlur Rahman, and Mr. Prashant Kumar Palani. Thank you very much for your amazing insight you gave into this FDP, and we are looking forward. We also have the program coordinator and head of electrical engineering department, Dr. Rizwan Farade, sir, with all the faculties and staff members of the electrical engineering department. We are happy to welcome the deans and heads of various departments of EE-AIKTC, faculties, students. Welcome everyone to this valedictory program. To begin this program, let us listen to the holy verses being recited by Yaqub sir.
Good afternoon. Bismillahirrahmanirrahim. A'udhu billahi minash shaitanir rajim. Bismillahirrahmanirrahim. Qul huwallahu ahad, Allahus samad, lam yalid wa lam yulad wa lam yakul lahu kufuwan ahad. Bismillahirrahmanirrahim. Inna atainakal kausar fasalli li rabbika wanhar inna shani'aka huwal abtar. Sadaqallahul azim.
Jazakallah Yaqub sir. Now I request the program coordinator and the head of electrical engineering department, Dr. Rizwan Farade sir, to give the briefing of this entire FDP. Over to you, Rizwan sir.
Thank you, Dr. Shahbaz. Am I audible?
Oh, yeah.
Yes, sir. You are audible.
Honorable Executive Chairman, Anjuman-e-Islam Board for in Navi Mumbai, Mr. Burhan Haris sir, Honorable Director, Anjuman-e-Islam's Kalseka Technical Campus, Dr. Abdul Razak sir, all the resource persons from various reputed institutions and industry, and participants across India and Kalseka Technical Campus. I would like to welcome all for the valedictory function of Faculty Development Program cum short-term training program organized by Department of Electrical Engineering. Given the time constraint, I would like to give a quick overview of the event. Firstly, this is a national level IST approved 1 week program on development, modeling and simulation of electric vehicles started on 10th of January with the intention to deliver the short, most recent trends and advancements in electric vehicles for academicians, research scholars, industry persons and students across the country. To reduce air pollution, EVs are the alternative to replace current fuel vehicles. Therefore, this program is designed with a sole objective to promote research interest and the future scope of electric vehicles. This program covered the fundamentals of electric vehicles and its components to the design aspects using Typhoon Hill software. This program will be beneficial for career advancement and accreditation. A total of 90 individuals were registered, out of which 33 participants from different parts of India and 57 were undergraduate students. In terms of percentage, out of 33 participants, 70% are teaching faculty, 4% are industry personnel, 11% are PG students, 8% are research scholar, and the rest are others. Lastly, I would like to congratulate organizing committee and support staff of my department at Anjuman Islam's Kalseka Technical Campus for their efforts to make this event possible. And I would like to thank higher authorities, Chairman Sir, as well as Director Sir. And I would like to request all the participants to please be in touch please be in touch for our research collaboration or our future events or the value-added courses in electrical engineering and software domain. Thank you all. Over to Shahbaz, sir.
Thank you, sir, for this briefing relating to the FTP. All right, so may I now request our participants to share their feedback, and many of them have given their names. By checking out the availability of time, we will accommodate accordingly. So starting with, we have first of all the student of EE-AIKTC who had been the participant of this FTP. So the student is Shahnaz. Shahnaz, can you please unmute yourself, switch on your video and share your feedback? Okay, we'll move on to the second person who gave, okay. Vedant Bayani from SP College is a student of SP College.
Yes, sir. Good evening.
Yeah, please share your feedback. Welcome.
Yeah. So, hello everyone. Good evening to one and all. I am from Sardar Patel College of Engineering, Mumbai. And yeah, and I am a final year BTech student. I came across this course through our basically our dean academic sir. They means basically email was forwarded regarding this course, and I am in electrical engineering department, and my area of interest is electric vehicle, and even my final year project is designing a electric vehicle charging station. So basically, I was very interested when this course was announced, and during the last 6 days, I actually have learned a lot. I really enjoyed the course. The course content was great. I'm so happy right now that I was able to learn what you could say an industry graded software that is Typhoon Hill, and I would like to thank AIKTC and the different professors and research scholars that gave their valuable time to explain regarding electric vehicle regarding the electric vehicle charging infrastructure, as well as the people from Typhoon Hill, the professionals from Typhoon Hill who actually helped basically helped to explain how this software works and how the modeling of electric vehicle as well as charging stations in Typhoon Hill works. So thank you, and I really enjoyed the course.
Okay, thank you, Vedant. We have faculty from KC College, and we have Aarti Bakshi, ma'am. Ma'am, could you please unmute yourself? Aarti
Sorry,
Bakshi,
sir.
faculty from KC
This
College.
is yes, sir. This is the colleague of the faculty, Aarti Bakshi. I'm also working as an assistant professor in the same college. We
Welcome,
both are registered for this course, and yeah, thank you. She was because of some sudden problem, she is not able to attend this. But on behalf of her also, and from my side also, I would like to thank all the resources we have given, the platform you have given. From even though we are from a different stream, we have enjoyed the particular STTP a lot because of the domain you have specified and the resources and the professionalism they've been given from the Typhoon Hill person. Those are actually interested topics we have all also gone through, and we are really appreciating this particular effort given by the industries also to the academician and even the students. So really we have learned a lot from the same, and future also regarding these kind of sessions you have conducted, we will be highly obliged to get those conductions again, and we would also like to have these sessions also in our college. We will try to recommend it for the same. Thank you so much for this so much knowledgeable sessions we have given. We have already taken from your side, and thank you so much for the thing. Thank you, sir.
Thank you very much, ma'am. So, anyone else who wishes to share the feedback? From like the students, the internal, the externals, anyone? All right. Okay. So, moving ahead, we wish to have our quick thought and sort of like guidance from our very director of EE-AIKTC, Dr. Abdul Razak Mutagi. So, sir is continuously, busy with, the strengthening of academics and all the host of things, which are very important from academia, industry, everything. He's continuously bringing out things for the overall development of the students, and this is also one of its product. So it's my sheer pleasure to welcome our honorable director, sir, Dr. Abdul Razak Mutagi. Sir is a graduate in civil engineering from Karnataka University, and he did his graduation in 1987, and then completed his master's in civil engineering from IIT Roorkee with the specialization in building science and technology in the year 1994. Sir received the doctorate of philosophy degree, that is PhD degree from IIT Bombay in 2014. Sir has more than 3 decades, 30 years of professional experience in the field of engineering education. And he began his career in teaching as lecturer of civil engineering in Karnataka and worked there for 10 years. Then Sir joined Sabu Siddhi College of Engineering, Mumbai as assistant professor of construction engineering. While working in Sabu Siddhi College of Engineering, Sir received the Best Teacher Award amongst the various colleges of Anjuman Islam for the year 1998-1999. Sir continued the art of attaining success through progression in his teaching and got promoted as principal of M.H. Sabu Siddiq Polytechnic, Mumbai. During his tenure, Sabu Siddiq Polytechnic was adjudged as the best polytechnic of Maharashtra state for the year 1999-2000. Also, the institute was cited as the role model polytechnic during 6th IST annual convention under the principalship of our director, Dr. Abdul Razak Mutagi. Sir has published numerous articles in international journals and has won outstanding research paper awards globally. In this way, sir has been capturing, the highest phases of his life, and he is continuously involved with, a lot of stuffs at Anjuman Islam's Kalsika Technical Campus. So without any further ado, I request our director, sir, to address the gathering. Welcome, director, sir.
Thank you very much, Dr. Shabazz. Respected and our beloved Executive Chairman, Mr. Burhan Haris Saab, under whose inspiration we are working here on this campus in Panvel, and also a few institutions in Wasi and Turbe. So he is the person behind all this from the management side, and also the entire Anjuman Islam and office bearers, Dr. Zahir Qazi, our president, who is a great again motivation for all of us, so that this campus can function really most professionally and as expected by the industry, by all the statutory authorities. So this is indeed a program which was timely thought, and let me congratulate first organizers, the Department of Engineering, headed by Dr. Rizwan Farade, and all his team of electrical engineering, and also the respondents in the form of participants. No, people will respond only to those programs which adds value into their training, into their curriculum vitae. So 90 individuals, 90 participants who responded externally, internally, and also from industry is really a great sign. That shows that the topic chosen for this short-term training program is very, very relevant, emerging, and therefore there is this kind of response. So you all deserve congratulations from our side, and these kind of programs, we do consistently in our campus. Just a week back, we had a program in civil engineering also, and that was also most relevant. And there, we provided a platform for many, faculty members and industry personnel, and it was hugely appreciated by Director, Faculty Development Cell of AICT, and he was our chief guest that time, and he was impressed looking at the profiles of all resource persons. In the same way, though we thought of inviting him for this program also, and because of some preoccupation, we could not get his time, but the kind of resource persons were planned for this most emerging field. It is really heartening, and it shows the amount of planning done by our Department of Electrical Engineering, and it also shows the interest, how they are keen to get connected with the industry. And that is the reason why this platform has been created for both academia and industry. So therefore, I'm very happy to convey you that there were expected outcomes at the end of this program. And when you read the objectives, and those objectives are well achieved, and according to me, I think the attainment level or the resource person who provided the information, the knowledge about this program is definitely attained more than 90%. So that is what exactly I can say, because I used to get feedback from Dr. Rizwan, and almost every session was going so well, and every participant was very happy. Only thing is, we could not realistically measure the participation of faculty members and other participants because of this program being online. So in online mode, it is very difficult to guess. So how much the participants are gaining out of the deliberations from resource person, that is again a big question mark. And even that is true for our classroom teaching in online mode. That is also always a problem, a challenge. But I wish, I assume that all participants were active, rather proactive, and they attended all the sessions. and they gained the required knowledge out of this training program. And as such, the main motto of Faculty Development Cell of AICT is to see that it is not only a certificate which faculty members are to be given, but the knowledge which is required to build their skills, build their attitude, that is important. And if you have gained that knowledge and attitude from this faculty development program, then only we feel we are successful. Otherwise, a piece of certificate which you get from IST, and that will add as one of the certificates for your career advancement scheme. If that is the motto, then it is only 10% of the requirements or objectives met. But what is important is whatever you have learned, that should be further disseminated to your students. Here, the end product or end beneficiaries are our students. So you all are here to ensure that our students will also get all this relevant information regarding the emerging electrical vehicles concept and modeling, simulation-based studies which are planned, in this program is really a need of the hour for our students. And when they carry this knowledge and they become relevant to the industry, and then again it enhances the placement avenues, placement opportunities. So all this is getting scaled in that direction. So therefore, I request and I appeal all participants, if you have really learned something out of this faculty development program, then please try to disseminate further down the line so that it reaches well to your students. So that is what we expect, and I hope you all faculty members take it very wisely. And this kind of programs you also need to organize, and this is a cycle to be continued for everybody. So therefore, our Khalseka Technical Campus motto is to see that every time, at least every semester, at least one or two departments plan such faculty development program that are very useful, relevant, and that is what our plan. And our IQAC is having already a plan in place, and therefore everybody has to conduct such programs, and it can benefit all faculty members, not only in the state of Maharashtra, but also across our country. And more participants coming from different parts of the country is an indicator that what kind of topic we have chosen, what kind of resource persons we are inviting, and that all matters. So therefore, we need to do all the time so that our message goes to the entire country and all faculty members of our country. So that is what our expectation. And I also wish that Department of Electrical Engineering and even all the departments and schools of this campus, it is a very interesting campus for the participants' knowledge. Let me tell, it is a very interesting multidisciplinary campus where we have got architecture, pharmacy, and many branches of engineering, post-graduation, PhD research center. And this is what exactly what is planned now in National Education Policy 2020. So by 2025, NEP 2020 wants our campuses to be multidisciplinary. And we are already in that direction. And we also have added non-AICT programs so that a large menu can be created, and that menu can be used by the students the way they want. So that is our journey. And our journey is also to see that we become autonomous. And over the time, we are also aiming at to be a technological university. And the people like you, the faculty members, your inputs, your feedback, your connection with our campus will help us. So we have got big ambitions, and we wish to be a lighthouse for industry in due course of time. So how to become lighthouse for industry, that is also in our blueprint. And only thing is we need to convert that into reality. This is what we are planning. And all this is happening, and it will happen by the grace of God, because we have got a wonderful, not only supportive, but participative management who knows the pulse of the time. And in that direction, our chairman himself, Mr. Burhan Haris, is the one person, whether even he is missing the actual visit to this campus because of pandemic, but otherwise he used to be here almost alternate day in our campus physically, traveling from Bandra to Panvel, and round the clock connecting with me, with all HODs, deans, knowing and giving his ideas, discussing about certain implementation, and especially in terms of development of our human resources. So all that discussion used to be carried around the clock. So that kind of care and concern our chairman has got, and this is how the entire body of Anjuman Islam's management and participants should also know, which in more details our chairman will deliberate. But we thank our management of Anjuman Islam who provided 100% full salary for entire faculty and staff members of this campus, even during pandemic while they were at home. But management chose to give 100% salary. There was no business to deduct any salary, so that it shows the concern, it shows the kind heart of our management, for which we are all grateful to them. And that is how the trust has been developed. That is how our chairman supports us. Therefore, we are very happy to be part of this organization. So once again, I congratulate Department of Electrical Engineering and all deans, all HODs who work energetically in this campus. And even in future, we keep doing good things. And I also welcome all of you to this valedictory program. And I wish to take this to your respective institutions in a positive spirit. So thank you very much for inviting me for this program to address you. Thanks a lot.
Thank you, sir. Thank you very much. So that was our Honorable Director, Dr. Abdul Razak Hanutagi, sir. Sir is already, on the move for an important work, but still, sir, made the time for this valedictory program. So we are extremely thankful to you, sir, for your amazing address. Thank you very much, sir. Moving on, may I now request our Honorable Chairman, Mr. Burhan Haris, sir, to address the gathering. And before that, it's my proud privilege to introduce sir with all of you. Can I ask the organizer to mute the participants, all the participants? There is some background news coming in. Mohsin sir, if you could. Mohsin sir, if you could. All right. So may I now, before I request sir to address the gathering, it's my privilege to introduce sir with all of us. So sir graduated in Bachelor of Arts from St. Xavier College, Mumbai, with the specialization in economics and Islamic culture in 1973. Sir has a strong entrepreneurial and philanthropic spirit with a solid focus on community development and upliftment. He started a small-scale industry named Fibratech Industry Private Limited, manufacturing crash helmets, sanitary wares, etc. at Kalyan in 1974. Sir then joined Aramco in Dhahran, Saudi Arabia in 1978 and worked there as manager and served there for 2 years. After returning to India, Sir started Maharashtra Salt Manufacturing Corporation Society Limited and developed 2 salt pans having the producing capacity of 5,000 tons of salt. Sir acted as founder chairman of the Manufacturing Cooperative Society. In 1992, he pioneered awareness and training on IBM by starting Syspro Software International Services Limited and developed this organization into a big concern with 105 people working under Sir's guidance. He kept on working towards establishing a total software organization, which culminated into the formation of Concourse Information Technology International Limited, with an expansion of centers in and beyond Mumbai, like Pune, Baroda, and Chennai. He was consulting CEO of Nimra International Corporation Limited, Bangkok, Thailand, Soft Origin Infotech Private Limited, Kenmore Technologies Private Limited, and the list is again very lengthy. Now, Sir is committed to social and educational cause by being an active member of Anjuman Islam, Mumbai, as the member of its General and Executive Council, as well as the Executive Chairman of Anjuman Islam's Board of Institution, Navi Mumbai. Sir is also acting as trustee of Ideal Education Society Rabodi and Shurparga Educational and Medical Trust Sopara. Sir's entrepreneurship and administrative skills are directing a dynamic and seasoned team of technical professionals to deliver quality educational satisfaction to the students of EIKTC through the timely and affordable education being supported by Anjuman Islam. I welcome our Honorable Chairman, sir, to this gathering. Over to you, Chairman, sir.
Assalamualaikum. Hello.
Yes, sir.
Namaste.
Assalamu.
Hi, hello. People from different ages and experiences and natures. Makes this gathering very interesting as it is. And they're all, or most of them, are educators, and the other, some of them students, who are looking for education, for knowledge, and who are here today, online. It's a matter of pride as it is to be part of an education system, educational, the resource, the people with the organization with only one intention of spreading knowledge, because knowledge being the most important and rare commodity today in the world, especially in a country like India, where it's required, it's need every day for, as it is, for the humanity as a whole. Education, knowledge, and it is, knowledge is full of oceans of information and learnings, and providing right material in the right manner, with the right character and culture is such a need of this world. It's not just taking a mic and speaking something, or standing in a classroom or saying something about the product. It's a matter of giving, selecting, choosing, studying, researching for right kind of material to be given, to be delivered to the people who are the seekers, who are desperate seekers, who understand the importance of knowledge, and who understand we're nothing without education, without knowledge. More and more knowledge every day, more and more education, sense of education every day. That need, that want, that craving for teaching. We are, me too, is part of those resources created by nature, I suppose. This is how I look at my job. This is how I think everyone involved to provide, to gain and provide knowledge. Even those who are gainers, I mean the students, have that, should have that attitude, should understand that we have a job, a responsibility, a biggest responsibility, put on us by Almighty nature. I mean, we are serving the nature, directly or indirectly. With those people who have a job of correcting, making world a better place to live, making world a place who is useful for other human beings and creatures of God Almighty. I mean, I'm not a Maulana. I'm not giving you a sermon. I'm talking for a practical sense, believe me or not. Do I look anyway, a person who gives religious sermons? I'm talking, I repeat myself, I'm talking practical sense. So, come back to me and come back to people who were managed the whole thought of this event like this, and those who are participating, who understood the right source, right material, right topic, right subject to be discussed and talked about and given knowledge on. Fortunate ones, those who understood what is required by the world outside, what kind of education and the way it should be delivered. All are people who deserve compliments, who deserves all the congratulations and mubarakbad. And there you are, and we could think of such an event, and we could go ahead and put it into practice, and held it for last 1 week with the right kind of people, all the resource people. My God, they are doing such a favor to us by participating every time we invite them. Thank you so much to today's resource people, and thank you so much on behalf of the whole world, on behalf of nature, for taking pains, taking efforts, checking ourselves out of our idleness and our laziness, and coming out and giving it to people. Thank you so much, everybody, and thanks, my great team. I mean, I'm proud. I know I have about 45 years of experience of about practical life, and I think we know we do this job from depth of our heart. We do it after a lot of thinking, proper thinking, that we do it right. We do it the way that, not just to plan a program of topic, plan a program resource people who can deliver some information on it, about it, some knowledge on it, and just invite people to participate more, थोड़े से हों या ज़्यादा हों, and then managing the whole affair. बड़ा काम है. Thank you for all of us, all of them, and thank Almighty that we all, I mean, I'm talking on behalf of every participant, every resource person, every person who was part of the thinking tank and part of managing the whole affair. Thank you very much. Congratulations for doing an honest job. That's how I feel. Only thing I'm a little sad about, and that is there were very few people to really to contribute to their thoughts about this 1 week affair, a 1 week event. I think when such an effort is made, it's really not easy job. We all know, you all know, but even the participants, what a good big effort it is. It takes so much of the institution, which is a community money, to community's resources, and then the more the people to give a billion, good or bad, I'm not saying praises, I'm not saying good about us, about the people managed like this. But even if it is negative comment, feedback, you're welcome. You should come forward. Next time you attend, sorry, next time you're there in an event like this, please be a little warmly hearted to come out and give your feedbacks. Thank you. There is so much to say, but I know after 6 days, 7 days, you must be all tired. Obi, this state of mind for the last 2 years, we all are in. Everybody in this big world, every part of this big world, going through, let's not mention, talk about it. Let's go ahead. But I can tell you one thing, that this industry have done a great job of using the online, the being forced being online to teach and learn, have done a good job, great job of using it online like this and keep passing. I mean, they did not let this go waste, to not do anything. And very easy. I mean, even being सबसे पहले जो सोचता है वो है about excuse. This industry have not given excuses, and I assure you, we have done a tremendous job in these 2 years of keep spreading knowledge and keep doing it right, and keep helping people to go forward and spend on educating themselves by whichever means. Thanks to the industry also. Thank God for making all of us think of doing something to keep spreading in spite of all the restrictions of the world where the academics and the governments and the management people have done a wonderful job, have done enormous amount of job. Thank you so much. Yes, you want to hear more? Because I have finished. Thank you.
Okay, sir. So, yeah, it was a pleasure hearing you, sir, so many days. And yes, we wish to see you into the campus. But yeah, the pandemic has affected us, all of us, in various ways. And we also understand your hardship because you are somebody who always loved to be on the field with the students, promoting, motivating the faculties, everyone. So yeah, we could understand your desperation, and even we also, miss you a lot, sir, at the campus. But anyways, having you online is again an amazing experience for all of us, and we always seek your kind support into all these kind of like initiatives, and these are all the product of your amazing guidance. So thank you very much, sir, on behalf of Anjuman Islam Staff Secretary.
Thank you, and please tell everybody in the campus that you're all doing a wonderful job. You are all, being part of, from the think tank to implementing things, wonderful things in this system. Your efforts by everybody. I'm so thankful to all of you. I do pray for each one of you. And I mean it again, I'm not a moron. It's a practical sense which I'm talking about.
Right.
Thank you.
Thank you. Thank you so much, sir. Thank you so much, sir. All right. So moving ahead, may I now request Professor Samir to propose the vote of thanks.
Assalamu alaikum to all.
Assalam.
Myself, Professor Samir Sheikh from Department of Electrical Engineering. On behalf of my department, I extend a really hearty vote of thanks. I wish to say thanks to Dr. Zahir Kazi, Honorable Anjuman Islam Mumbai, our respected J.R. Sheikh, Honorable General Secretary, Anjuman Islam Mumbai, our respected Mr. Burhan Haris, Honorable Executive Chairman, Board of Institution in Navi Mumbai, and respected Dr. Abdul Razzaq Hanutogi, Director, Anjuman Islam Kalsegar Technical Campus. I would like to thank Program Coordinator Dr. Rizwan Faraday, Event Coordinator, Joint Coordinator, and faculty members of the event, and all the staff members who support this event to happen. I wish to say thanks to all participants and all the resource persons for their efforts. Thank you very much. Over to you, Shahbaz sir.
Thank you.
Yes, sir. Thank you very much. So that was all from this FTP. And again, I wish to thank and congratulate all the dear participants for the learning you all have taken, and a lot of things coming up from the Department of Electrical Engineering in the near future. So thank you and congratulations once again. The certificates will be shared with you all through your email ID as per the proceedings of the program. So please don't worry for that. Now I request all the participants to please switch on your camera for a group photo. I request everyone to switch on their camera.
I think I'm better off, huh?
Yes, sir.
With this, these I'm not seen, I suppose. You know, नजर तो आना चाहिए. सब छुप जाता है इसमें ना. जो नहीं छुपना चाहिए वो भी छुपता है, जो छुपता है वो भी.
Come on, guys. Yeah, all of you, please switch on your camera.
Dr. Shahbaz.
Yes, sir.
Hi, sir. बुरान साहब और चेयरमैन साहब का क्या चीज छुपी है?
क्या बोले?
कुछ तो छुपी है. आपकी कोई चीज छुपी नहीं. कितने ट्रांसपेरेंट हो.
Yeah, come on, everyone, very quickly. Yes, yes, yes. Yeah, all of you. Okay, the first page is done. Okay.
कौन है इतना अंगार फैलाने वाला?
Mohsin sir, could you please mute everyone? Yeah. Yes. I'll take one more. All right, the last frame, everyone. Okay, please have a happy smile. Thank you so much. So that's all from Anjuman Islam's Technical Campus. And we were the Electrical Engineering Department. And from every one of us, thank you very much and congratulations for the learning. Thank you very much.
Thank you, sir. Thank you very much.
Thank you. Okay, we will sign off now. Thank you. Okay, Mohsin sir, do you wish to make an announcement? You can unmute yourself.
So, all the participants, there is a test link forwarded in the group, and it has a time frame of 5:30 to 7 o'clock. So I request you to kindly fill up the test as soon as possible.
Okay, thank you, sir. Noted. Thank you. Thank you, Chairman, sir. Thank you, Director, sir. Thank you very much. Yeah, bye, sir. Allah Hafiz.